I welcome you all for our third session of numerical concepts of strictly pure math, and we are going to handle logarithms. So I believe whoever is here completed indices and is here for logarithms, then later on we shall end with SADs, as I told you, and then topic 1 shall be dusted. Of course, it's the very first topic with only 3 subtopics, that is indices, logarithms, then SADs. So we are here to introduce this topic. Every concept under logarithms is going to be talked about today. So we are going to do most of the things now. Maybe if we are to have some other session, it will be purely revision. So thanks to the person who gave us an opening prayer. So as usual, without wasting time, you will allow me as the audience just a minute to talk to those people who are attending this for the very first time. I tell them about the tute and I tell them about Science Scholars Academy. Then we can begin. So logarithms are very cheap. I don't want you to be stressed, but they disturb so many students. I don't know why. So we are going to talk about their laws that really govern them, and we see how best we can apply them. Though I need a timekeeper, because I want by the time people start to live, they really live with content. But I'm going to brief you more about the time management. So let me use a minute to talk about the people who have sent me to come here and teach you logarithms. So have been sent by Science Scholars Academy, SSA. So some of you already know me, some of you don't. So those who don't know me, I'm by names of Dr. Paul. Yeah. If you want to really look at my other names, you can try sending me money on my number and you'll see the other names. So you can call me Paul Tutor, or you can just simply call me Doctor, as most students do. So the vision of the academy that has sent me to be here with you tonight, its vision is to create scholars of science that are competent enough in the country. And of course, you will see next week when they release results of candidates of 2025, you will see our candidates shining, of course. And you also shine in 2028 when your results are back. Okay. Now, we only handle 3 services, or that's what we deliver. I told you about the homeschooling program, the one that is really taken on by those that solely study from home, then the day scholars who catch up with us at night, early morning, and then weekend. You get? So it's purely normal school program. Everything that happens at school actually happens under homeschooling. Apart from things like attending to the school nurses, apart from physical things, but the rest of the things, practicals, everything, it's just a full package. Okay. Then the other thing that we do is the holiday coaching program, the one that happens in first term, second term, and third term. Usually in senior 6, we have covered enough work with you, we have revised enough. We don't even need you to come back for coaching because we shall have given you all the content you need. Unless you're just coming back to be fine-tuned. Things like that. So the coaching program usually goes for 100,000 for the whole combination. So if you know math, it's 5K per subject per week because holidays are normally for months. So you can do the math and see. So it's that fair and cheap. For homeschooling, that one you just talk to the tutors who are going to handle you. You negotiate and study. The other free services we offer to students, it's advice, counseling, and consultation. You can never consult me when I'm free and I don't help. We also have a team of consultants that I provided in the channel. Things like that. So the subjects are majorly 4: biology, chemistry, math, and physics. The live lessons are covered via Zoom. So have it in mind that we are currently on Zoom, apart from those who will later on have the recorded class. So some of them are going to watch it from our applications and Scholars app, others from Google Drive, others from YouTube. So it depends on which kind of a lesson. Is it a premium one or is it a free class? Things like that. So once you get in touch, this is of course our contact. Once you get in touch, we can guide you on how to access all the work, whether you're at school, whether you're at home, you see, whether you're at home, whether you're at school, You can just take a screenshot of that. You can even read through on your own later. Yeah, that is our email for the corporate students who want to communicate via email. So even the subsidiaries, Sub ICT, Sub Math, GP, and yeah, they are all facilitated. So the recorded classes we've been having ever since 2016 have always been recorded, and we fine tune them, we pick the best. So they are always available 24/7. You can review them and just cover work, revise, do exams. May God leads you, you pass, get your target points and leave. So our products are just summarized notes, but I told you these ones are free. There is none that we sell. We sell none. We just provide them to the premium students, those that enroll for homeschooling, coaching, things like that. Like the one we are going to use today. It's also part of our e-library, so you get it. After all, this is a free class. Hope that is okay. So for those who want to look at more sample classes that are free from YouTube, you can check our channel. It's Sun Scholars Academy UG on YouTube. So that is it. So thank you for giving me that chance to talk about everything. So we can now have our class, logarithms. So I really want the lesson target to be introducing all the facts about logarithms, and then maybe it's the application that will delay us here. But as far as the knowledge and concepts on logarithms are concerned, I want to use the very first hour when we are done with everything. Yeah? Then the other time is just for looking at the different numbers. Hope that is okay. So the lesson targets, you all know, those we recall, we looked at the syllabus book the other time, and they need you to look at the relationship between a logarithm and an index. They want you to look at the logarithmic notation, then the laws. So these are the things we are going to look at. And then we are supposed to apply logarithms to solve equations. Hope that is okay. So those are the things we are going to do here. Nothing much. Remember telling you there are things of simplifying expressions. We are supposed to do that also. There are things of proofs. We are going to look at some also. And then we see where we can end. So just stay on, stay calm, get your books ready. You write what you can. I'll also give you a chance to take a screenshot where necessary. Things like that. So that is going to be the order of the lesson. Hope you are together now. So the lesson targets are very obvious from the book. Yeah. So these ones have been taken. These ones have been taken from the syllabus book. At least I believe before this class ends, we shall have looked at whatever is there. Then you'll go with research, you'll go with assignment. So one thing that you should know, we can never leave a class. Those who have been with me those who have been with me for some time, you know, you cannot leave a lesson without research, without assignment. Without research or assignment or both. Then after that all, I'll tell you what our next stop shall be. And I told you the next stop is always all about you making research still. So that will be the end of the class. So tighten your seatbelt. So you'll have your supper as you're attending the class. Is it okay? Now, without wasting time, I'm going to introduce logarithms. Most of you don't even know what a logarithm is, but you know how it looks like, even those who know the topic already, and you've come here for just a few concepts. I believe you cannot define for me a logarithm. That I'm sure you can't. But you're here and you can do serious numbers about the topic. So logarithms, let's introduce them. So introduction. So as we introduce, I want us to first define it. because I believe most people know how it looks like. Okay, people are not hearing the word for the first time. You've seen a lot of question papers having these things of logarithms, I believe. Now, the word is logarithms. That is the full word. Of course, logarithm, singular, logarithms, pro. That is the word. So it is abbreviated as, all of you write the abbreviation in the chat. Abbreviated as, someone is writing in the screen. I know why some people are disorganized. The moment you write in the screen again, I'm going to remove you and you're not going to come back. So please behave. You waste our time every time you write in the screen, so behave. So we just abbreviate it as log. Someone may be like, is it really capital letter or what? Usually abbreviations are small letters, eh? But this is mathematics. Even if you write log with capital L, no one really cares. They will just leave you. But the best thing is that small l. That's how we abbreviate it as log. So when you see log, have it in mind. We mean logarithm. Is it okay? So most of you know how it looks like in most of the cases, how it is written. Is it okay? Now, let's first write it without even wasting time. Let me write here log. Let me also write here log. Let me also write here log. So I'm going to write three things. Then people, you're going to choose which one is the right thing. I'm going to use X and Y only. Okay, let me use A and B. So the first one, I'm going to write A here, then B here. Are we together? Then I'm going to write A here, then I'm going to write B here. Then I'm going to write B here, then I'm going to write A here. Those things are not the same, they are different. Which one is right? We have the first one, we have the second, we have the third. Which one to you looks correct? Or which one to you looks more correct? If you don't know, you will tell it to write for you log of 3 to a certain base. Let me see what people are choosing in the chat. Which one is the correct one? You see, people are saying 3, 1, you see? People having different values. Someone is like 1 and 3. Okay, people are choosing everything. There are people even who are choosing 2. Hey. So which one is correct? Which one is correct? That means people don't read textbooks. This is where normally textbooks come in. But I'm kinda disappointed. Because everyone is now choosing all numbers. But I think most people are going for 3. Okay. That's not bad. That's not bad. You tell me any textbook of math that you know in the chat. Tell me any textbook of math that you know in the chat. Okay, let's leave the textbook. But when you go to the internet and ask it to write for you, you're going to see the format. You people, this A here in the second option, this A is very far. It's looking like a power to the logarithm, which is not right. This A is right. Okay, okay, people. So we are going to be using the third option. It's the best one. Someone may be like, what's wrong with the first one? The first one, you can rate it. No one will even give it time. No one will give it time, trust me. They will just mark. But the problem with it is that it's like they are in the same line. But it has no problem. People write it, people get marked. But for me, I'm going to tell you what I prefer. Okay? Then this one, the A is very far. It's like a power, so that's why it's out. Then this last one is what I prefer because it really brings out the number that we want very well. Okay, it gives the number and the base their own territory. That's why I like it. That's why I like it. It gives the base its own space and territory. It gives the number its own space and territory. So we are going to be going for the last format. So even as you're writing your work, please respect the fact that that's how it's supposed to be best written. So an example. So an example. So we have chosen the best of how we are going to be writing everything. So um so we are like written like log. So I've chosen to have the base here, then a here, like that. Don't you see that that thing really looks good? The a is in its own space, even the base. So that is how we write it. Now the question is, how do you read it? So you read it for me in the chat. Read it for me in the chat. Read it for me in the chat. How do we read? Yeah. How do you read it? So you now know how things are supposed to be written. So if I mess up, just now I'm just trying to be fast. So how do we read that? Log A base B, log A of B, log B power A, log A of B. Oh, eh. Log A B, log A base B, log of A base B, log A B. You people, you're really very bad. Log B of A. Eh, that is very bad if people can't even read. You see, someone there is really complaining, saying, for us, we know those things. Go directly to the laws. I cannot teach you laws for something you can't read. And we cannot read something you can't write. So please, now allow me take the lead. Allow me take the lead. So if you're to read that, at least first understand and appreciate that this B is the base. In whatever you're doing, have it in mind the B is the what? The B is the base. The B is the base. So if you're to read it, you're going to say, if you're to read, you're going to say log. You have too many options. Log of A to the base B. Are you listening? Like it is the log of A to the base B. Are we together? Log of A to the base B. That is option 1. Option 2, how else can you read? You can simply say log A. The people who don't have time, they just say log A base B. Log A base B. But I'll put half a tick because it is very weird. The best statement is log of A to the base B. But people say log A base B. But I'll put a half. That is weird. But people use it. Then the other thing, people say, simply say log A of B. I also put a half there. So when someone reads log 2 of 3, have it in mind, log 2 of 3. You understand? So those are the only ways I expect you to be reading. If you have any other way, then that is upon you. I don't know about that. If for you say log A of base B, it is the same thing. B is a base. But you should be rotating around that. But the best option as a mathematician, it is log of 3 to the base 5. Even me as I'm speaking, I'm going to be saying log 7 on 9. Log 7 of 9. I'll be saying those words. Log 9 of 7. Just to be a bit fast. But the right word should be log of 7 to the base 9. Log of 9 to the base 7. This is an academy, so we are supposed to give you the math. Okay? So, this is the best. So that is done. Now, I want to pose a question. When you say log of A, log of A, log of A is our number. That is one thing I really want you to appreciate again. When you say log of 2, log of 5, log of 10, log of 9, log of what? That thing you're reading is, of course, the number. You cannot give it any other name. You cannot give it any other name. Okay? But then before we even go any further, so we have agreed that this A is always our number. You can call it number, you can call it integer, whatsoever. I don't really care, whichever you want. So this one, I'm like, it is the number. I want you to go in the calculators. I think we did that in the previous lesson. All of you press log of negative of any number. Log negative of any number. Put in any number that you want. Put in any number that you want. Put in any number that you want. Log of a negative of any number. What are you getting? Tell me in the chat. You're getting math error. That means you're supposed to only and only get logarithms of positive numbers. So I'm going to edit this and say that that A is a positive number. Positive number, or people call it positive integer. Are we okay? So this one has a name already. It is the positive number or positive integer. The B has a name already and it is our base. Are we together? Now, 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 this is my question. So I have an ask. If at all, you have something like this, log A of B maybe being equal to C, something like that. So we have already named. We have said that this one is a what? It's a positive number or integer. Anyway, as I write these ones, you realize B has a name, even A has a name, but C has no name. Who knows the name of C? Tell me in the chat. So we are saying that our A is the positive number or integer. Then we said already that this B is the base. So all I want to know, what is the name of C? Because you people, you press log 100 in the calculator, you're going to get 2. So you're getting a certain answer. So look at that 2 as the C. So what is that 2? See if people really know. Oh, you people, you're very knowledgeable. You're very knowledgeable. I think people know it. It is the power. Thank you so much. But someone may be like, why are you really saying that it is the power? So this is where I'm going to define a logarithm from. I asked you one of the textbooks in math, and someone told me Backhouse, and I also carried Backhouse with me. So let me check. Backhouse is one of my favorite books in math, especially pure math. Yeah. Then to do with applied math, there are also other books of H.J. Sadler of understanding mechanics, understanding probability, numerical concepts, and statistics. So I think algebra is chapter 9. Yeah, it's here. Some useful topics in algebra. Logarithms are here. Let me see the page. Which one is it? 177, 179. I can't see. But let's check there and see. Okay, 179. Okay. Okay, I think we need to scroll more. This is one of my best books. So I want us to take the definition Backhouse gave us, the one of logarithms. Okay? So I think they are the ones here. Yeah, they are here. I remember reading it sometime. Let's see if it's really still here. Yeah, let's read K textbook for the very first time. Logarithms. They are saying that readers will probably be familiar with the use of logarithms for multiplication and division, but there are certain properties of logarithms that are useful in more advanced work. Having just considered indices, this is the appropriate place for logarithms because a logarithm is an index. That's what I wanted. Are you seeing this thing? A logarithm is an index. A logarithm is an index. That is the definition. Leave alone these other definitions they give you in books. Those definitions will confuse you. Backhouse simplified everything and told us that a logarithm is an index. So even when you go back to school and the teacher tries to ask you to define, just tell the teacher a logarithm is an index. You can even tell the teacher logarithm is a power. You stop there. They ask you, can't you add on? You tell them I can't. Even Backhouse stopped there. Who am I? Said what da. You see? So the definition is simple. The definition is logarithm is power. Or you can call it an index. Now, why I'm deciding to write it like that, I want to relate it to math. I've just converted the other English to math. That a logarithm is a power. A logarithm is an index. So every time a logarithm is equated to anything, that anything it is equated to is always called the power, is always called the index. So it is always the what? The index, it is always the power. You learn that and understand that. Hope we are together. So all logarithms, because we are in the end going to look at how they relate to indices in this very class. Trust me, if you don't know that what a logarithm is equated to is a power, you're going to struggle so much. So that is enough, and I don't want to say much about it. Okay? And I want to straight away proceed to indices a moment. So strictly and slightly back to indices. Then we look at how they relate, then we begin the rules. Back to indices slightly. I talk about natural logarithms, we talk about the rules of logarithms, then we start applying them anyhowly. I think 40 minutes are even enough for me to reach where I wanted to reach. So back to indices slightly. Those who attended the class that we had, I remember telling you that for here, let me use, I think, x, y, and z. So if I have x, and then I have y, and then this side I have z, because if I use a, b, and c, I may confuse people. X, y, then z. I want you to tell me the name of each. I want you to tell me the name of this, but we are now back to indices, so make sure you've switched your mind. Tell me the name of this. Tell me the name of this. Let's begin with the most obvious. I want 5 people in the chat to tell me the name of x. How do we call x in indices? How do we call x in indices? X is the best. Those people are enough. I now want 5 people to tell me, then y. So you're saying x is the best. Now we are going to y. X is the best. Then what of y? What of y? Y is the power or the index. Good. So this last one, remember I always said 2 power 3 is 8. You see? It'd be like 4 power 2 is 16. So it's like this is the chi number you are getting, the chi answer. So this one is always our number. That is always our number in most of the cases. That is always the number. I've told you. Now, there are a lot of things you're going to encounter here. But of course, I'm going to brief you. Just don't worry and don't panic. Everything is under control. So this is the chi number, it is the chi integer we are getting after doing whatever we are doing. And even after all, the names of the base and the name of the power. Okay, after all, words like base and power have already been taken. So the balance has no option other than taking on the balance. So I don't want you to overthink whatever I'm covering now. Don't overthink. So you just understand what I'm saying. Don't overthink about it. So this is what I'm saying. You're having um you're having P, log of P of Q, maybe you're equating it to R. So we are saying that Backhouse said, that person who said they have not understood. Backhouse said that a logarithm is a power. Remember, a logarithm is full if it has a base and the number we are dealing with. It cannot be full with just the word logarithm. No, it is supposed to have its base, it's supposed to have its number. So Backhouse said a logarithm is a power. And when you convert that definition into mathematics, it is log equal to power. So anything the logarithm is equated to is called a power in simple terms. So in this case, the whole of this logarithms is equated to R. So this R is our power. Up here together now. Then this Q, everyone knows it is the base. Then this P, everyone knows it is the integer in place. That is what I want you to understand. After understanding that, come back and understand something else this side. That if you're having S, let me not use S, that if you're having T power U and then it is equal to V. Now these are indices because we don't have log anywhere. Everyone knows that since it is T power U, then T is the base because it's the one carrying the power. Which power is what? Is U. Like that. Is it okay? Then this V is the answer we are getting. It is the answer. It is the number. It is the answer. Nothing much. So it is the number. It is the integer. Of course, integers are numbers in math. They're just anonymous. Integer. That's what I want you to understand. Nothing else. And hope you are together there. Now, what I want us to look at. So according to the syllabus book, we have covered the logarithmic notation. Now, I want us to look at how they relate to indices, and then we look at the laws, then we start applying. So don't really give me a time and say, you're not getting, you must get. Now, let us look at how we can convert. So we are going to begin with converting. So one, so that's how they relate. They relate by sharing names. A log must have a base. Even something in index form. Okay, we are having side one, then this one, we can call it side two. So how they relate, this side we have logarithm, this side we have it, the other side one logarithm, side two indices. So how they relate, each of them should have a base, each of the sides should have a power, each of the sides should have an integer. And that's how they relate, because they share the components. Though the components occupy different positions, and simple as that. So let's go. We are now going to convert. What should we begin with? Let's begin with indices to logarithms. So we are going to convert indices to logarithms. So I want you to listen. So the first thing, I'm going to put it here, part A. I have A power B equal to C. Then they tell you that help us and convert this into a logarithm. So the question is, what do you do? So I'm here to guide you. And this is what you do. If at all they tell you that we want this one as a logarithm, first write the word log. After writing it, ask yourself, which positions am I supposed to occupy? Be like, I'm supposed to occupy that as the base, I'm supposed to occupy that, which is my integer. Then I should put equal signs, and then I should occupy that. And since I will be equating the whole logarithm to something, what I'm supposed to put here is the power. So after doing that, now come and ask yourself, what is this A? Be like, this A is the base. So you come and put this A where we have the base like that. I don't know if we are together. Said you come and put that A there like that. Then you ask yourself, what is the name of this B? This B is the power. Then ask yourself, of this position, this is position 1, this is position 2. Which one is the position of the power? Tell me in the chat. Which one is the position of the power? Of position 1 and 2, which one is the position of the power? Which one is the position of the power? Thank you so much. It is position 2. So since the power is position 2, now you come and carry the power that side. So I'm going to come and put the power here, B, like that. So this one is the balance, even if you don't overthink. But it is your answer, it is the number, it is the integer. So it just comes and sits there like that. Then you're done. You're done. That's how it's supposed to look like. So, do you understand now how they relate? Understand the name of each, understand the positions they occupy. Then the conversion will just be nice. 0K. Let me do something else here. Okay, part B. Part B. Look here. We have P power negative 2, power negative Q, sorry, equal sign. Then I'm going to give this one R, like that. Then they tell you to do that. Now I'm going to, okay, let me first brief you. So you all know, if you're to convert it into logarithm, you're supposed to put here log 0K. Then you're occupying 3 positions. This position, then you put equal sign, then also this position, isn't it? Now I'm going to use arrows. You'll be telling me which letter to put. So this is our thing in index form whatsoever. So my first question is, which one should I put here? That is where the arrow is pointing. What should I put there first? Tell me in the chat. What should I put there? What should I put there? What should I put there? You see someone is telling me P. That person is not following. So you please inbox them and help them. Someone is even saying negative Q. You see that person is not following also. So what we are putting there is R. What we are putting there is R. Okay, thank you so much. What are we putting here? That is the second arrow. What are we putting there in the chart? I think now this has been understood. Thank you so much. Negative Q. So, you people, that is it. The format of attempting this will never change. So the P as the P is the base. So because it is the base, it will come here and take the position of the word the base. Then the whole of negative Q is what we call the power. And you know the position of the power in the log form. The position of the power is this side after the equal sign. So I will come and put there negative Q like that. So since we always say log of R, log of R, log of this, that this is always our number. And it is even the leftover. We don't expect it to take any other position apart from this. So what do I advise? Always first secure the base and power, then other things come later. That is always the best way. So you can later rewrite it well, log R of P equal to negative Q. So that is it, people. So I don't really think I need to do a lot of numbers. I don't. Now let me talk about option 2. Now we are going to convert. Let me see if people will do the first one. If you fail the first one, then I'll do it. You do the second. Then I think I'll give you some small assignments. Okay. So I think let me put the assignments just below that. Then people should take a screenshot of them. So assignment. So this one, I want you to handle do for me x power a equal to y. Then you do for me y power negative this equal to b. Those ones. So you're converting those ones into logarithms. I don't want very many. Those are enough. Yeah. Okay, now let's now do the reverse. Try to convert logarithms into indices. So we are converting logs into indices. So the first one is yours. That also chip in, okay? So we are having this log. Someone is writing in my screen. I really stopped you from that. You're disorganizing us. So the first logarithm I have, okay, we are going to have logarithm of we are having w, we are having v, then this side we have negative x. Is it okay? So if you're to convert it into something in an index form, of course you need something here, then you need something here, then equal sign, then you also need something here. Okay, now very fast, I'm beginning with this. What should I put in the circle? We have the circle, rectangle, and triangle. So what am I putting in the circle? Tell me in the chat. What am I putting in the circle? Some people are telling me X. Why are people telling me X? You see, people are confused. Someone is telling me Y, and we have people who have Y. There are those who just have X, just which is wrong. Someone is even having V. You see? But I told you the reason I try always give you a chance to say something in the chat. I want those people who are not really following up to inbox those people who are giving incorrect answers. Inbox them and tell them to help you out. Something like that. Hope we are together. Now, people have said X. What am I putting here in the triangle? What am I putting in the triangle? Triangle, triangle, triangle. Okay, I think people have understood, yeah? So for this one, we are going to just stop on that. I don't know if I will. I have not considered anyone, but I can briefly and stop on that. So you all know that V is what they call the base. So because it is the base, it will take on this position. Is it okay? Then you all know this negative x. Since the whole logarithm is equal to the negative x, what does that imply? That implies that negative x is the power. So it should take on this position of the power. Is it okay? Then the other side we always have our answer, the number, the integer. And you all know when they say log W, W is the integer, the number, positive integer, things like that. So we shall have W here. And then that is it. So I don't think I really need to do a lot here. I think that is enough for the relationship. We can proceed to the laws. The laws, we are going to just simply state them because the curriculum tells us to state them. But the old curriculum requested us to derive. So I'm going to just simply do what? Give you the laws. Then I will ask you later on to do research work and watch videos of how they are derived. Don't cram the derivations, but just watch the videos to appreciate the beauty of math. Just that. So I will immediately add you for you, provided you secure the position of the power and the base. That is always enough. Okay. Now assignment. I don't really have to go beyond that. So assignment, it is B and C. So you will handle this. So you will do for me C, B, then this one A. Okay. Then you also do for me this. Yeah, I think that will work. So just try those ones. And so your students have done those assignments from the Zoom chat and they are done. So they are waiting for other assignments. Okay. Now, if I go to the syllabus book, the relationships have been ticked. Now we are going to go to the laws. Now the laws, I don't know if we are on time. I wanted to use less than an hour to be done with the laws. So the laws, be extra attentive. I don't want you to tell me to repeat anything. So according to the syllabus, even the relationship, we are done. So we are now going to go to the laws, then we start applying them. Because deep down, I know the people who are here actually know the laws, but how to apply them really gives them a thing. But I'm also not going to do a lot about application. Yeah. So the laws of logs. After all, I gave you the abbreviation. Why do I need to override? So the laws of what? Logarithms. Okay. Now, these ones are related to those of indices. Yeah. So they are kind of, because when I just say related, people may judge me, but they are kind of related to those of indices. So the question should be how. So you should just be knowing those of indices so that when I brief you, you really get it. Now, there are some special things about logarithms, but I'll tell them to you at the end. Right now, you don't need them. You have to do with natural log. Why I don't want to waste time, I taught natural log under differentiation very well. And when I start, I may not stop because it's one of the things I like most in math. Okay. Now, what are we going to do? The very first rule. Okay. And people know it. So this is what we are going to do. We are going to have, so you know how logarithms look like. So we are going to have log A to the base C. Then we are also going to have log B to the base C like that. So what are we really doing here? I told you with mathematics, you don't need to have the literature, but get the literature from the tutor, look at the mathematical expression, and that is all. So here we are having logarithms, logarithm. Okay, we're having log and log, and they are to the same base C. What is different are the numbers. Do you recall those things? In indices, we are saying same base, different powers, we add the powers. I know that people are recording that. In indices, we are saying if you have c power a times what? C power b, we are saying that get c, then say a plus b. I know that people can remember that. But remember in indices, this was what? This was multiplication. Now here logarithms, we are adding, but remember those two are sisters. We agreed that product or multiplication is a sister to addition, and division or quotient is a sister to subtraction. So even in logarithms, we are going to do kind of the same thing. What do I mean? We are going to have the logarithm, since it is the same base, so it's going to come out as 1. So we have log to the base c combined. Now, what are we really going to do for these numbers? Since here we added, so the other side we are going to multiply. And when you multiply a and b, you come up with what? A b. I don't know if people have gotten this. Have people gotten this? In indices, we are saying c power a times c power b. Because c, same base, keep it as 1. These different powers, because they are multiplied here, add the powers. You get? But now logarithms, we don't multiply them. For them, they are only added and subtracted. So we are like, even in logarithms, we are seeing kind of the same thing. Kind of the same thing. And how? That in either of the cases, we are having the log, we are having the log. We are having the same base c, we are having the same base c. So what is the resultant? Since we are having log and base c, we shall first make it as 1. The way we first made this base as 1, and then we come and say, here in indices we say these different powers, because of this multiplication, we just add them. Because multiplication and addition are brothers. Now here it's the reverse. We ask ourselves, what are we going to do for these numbers? But we be like, here the logarithms were added, so why don't we just multiply the what? The numbers. That is the first rule and the cheapest. I don't know if I've left anyone behind, because I know logarithms were removed from your curriculum of O level. So I don't want to leave you behind, because this is one of the most common laws. The moment you miss any law in logarithm, you can never pass them, because they usually work together. They usually help each other. Hey, you find step 1, you apply law 1. Step 2, another law, like that. You can find a number that is really taking on all of them. So you need to be very sober. So for me, I'm going to the second. So hope I'm moving with everyone to the second. I don't have time to open the chat. Simply raise up your hand and immediately ask where you're not getting. If it is network, you wait for the recorded lesson. It will be uploaded on YouTube. So we proceed again. What if you're having log? What if you're having the same thing on the left-hand side? Log A, you're having C here, minus, you're having log, you're having B here, then you're having C here again, equal sign. So you all know subtraction and division or quotient, they are sisters. To take you back a bit, we used to say in indices, so here we are having a similar base of C. So in indices, we said when you have C power A and you divide it by C power B, we said because this is C and this is C, first now maintain it as 1. Then because the powers are different, okay, we have now different powers. Because of this division, we shall now subtract the what? The powers. Now with logarithms, you're having log, you're having log, you're having base, you're having base C. Common things. Now first make it as 1, and it is log to the base C. Are we together? Now ask yourself, how am I going to deal with these different powers? Then you be like, here they what? They subtracted. If they subtracted, now let me divide those numbers. Because subtraction and division are like this. Sisters. So what will I have here? I will have now A over B. Let me hope now people get what I meant by kind of related to indices. So are we still together? Are we still together? So I'm removing this. Hope people are taking notes. Hope people are understanding. I'm not checking the chat. I'm simply only responding to those who can raise their voices and speak up. And trust me, those are the basic ones. Yeah, if you don't understand those ones, even the rest you won't. Yes, even the rest you won't. You like it or not. So make sure those ones, the point has been what? Taken home. Okay, now, what is the third one? Very cheap, very cheap, very cheap. Let's come here and rate it. So the third one. The third one is more of a fact, but understand it. Have no choice. If at all you happen to get something like this, you're having here base C, then you're having here the A, but this A again is to power B. Are you seeing that? You have something like that, and then this one is to power B like that. What do you do for such a thing? So logarithms have it that, or have a rule that tells us that the moment your number has a power, you can literally get this power and then bring it before the logarithm. So it becomes like b times the logarithm. You get? So it becomes like b times the logarithm. But you all know, even if I just write b log, but of course there is, okay, when you see a b, there is a silent multiplication. So even when I also say b log ac, you see that? Hope you understand. Are we together? So the moment you see b log, that means it is b times log. Every time we have two things together in multiplication, okay, every time we have two things together in math, there is some silent multiplication that has happened. Hope that is clear. I know deep down people want me to first relate it to some things. I think let me do that for you so that people um but again, application is better. We are going to handle everything at once. First understand these cheap ones. Yeah, first understand the laws as they are. Then when we start the numbers, everything will be making sense. Yeah. Now, there is something else that we talked about that I wouldn't want us to leave out. Hmm? Uh-huh. Point 4. Convert. Let's convert, all of us. I think someone is supposed to choose for us. Okay, you all know that a power, convert that one. A power 1 is A. Is it right? Is it right? What of a power 0? What is it? A power 0. A power 0, what is it? A power 1 is 1. We said anything to power 1 is that thing. Then we said anything to power 0 is a 1. Okay? Now we are converting those two things. We are converting them to logarithms. Eh? Convert that one to log. Then you're also going to help me to convert this one into log. The things you're going to get are now also rules or laws of logarithms. So we are going to put here log. Let me first give people a chance to speak. So you all know logarithm. There are three positions that we are supposed to substitute for. I want someone to unmute, raise up their hand actually. If you know you can convert for us those things well. A to power 0 is 1, yeah? It was just I just miswrote that, sorry. Okay, so we need this position, that one. We also need this position, this one. Then the other one that comes after the equal sign, like that. So do I have anyone who can really, do we have anyone who can really tell us? But this is what we are going to do. This is what we are going to do. Okay, let me pick Michael. Yes, Michael. Michael, are you ready for the first one? The second one should be a girl, so a girl should be ready for number 5. So Michael, you're on 4. What should I put here? I don't know why Michael is quiet. Michael, kindly unmute and speak. What should I put there?
You should put there A.
We should put there A. Why? Because, can you tell us why? Why A?
Because from our first item given to us, we have A to the power of 1 is equivalent to A. Meaning, we should have
We should
the
have A
value there.
as our number, isn't it?
Yeah, it's the integer.
Okay, what should I put there?
Should also put there A because it is the base.
Then what should I put here?
It's 1.
Thank you so much.
You're
Then,
welcome.
where is? Who next? Who next? Um, okay, I think Leah. Leah, unmute and tell us the second. Are you ready?
Yeah, I'm ready.
So what should I put there?
Put 1.
Put 1,
Yes.
because 1 is our number, of course. Then what should I put here?
Put 0.
Put 0. What should I
Yeah.
put here? The last one?
Put A.
Because it is our base. Thank you so
Yeah.
much. Thank you so much. So people, that's how cheap those things are. Very cheap. Very cheap. So this is what I want you to realize. Let me remove the arrows and the circles. Then you realize something. Because the arrows and circles may hide something that I really want to show you. So this is the rule in logarithms. Every time you're dealing with log of a certain number to a given base, and these two things are the same, that one is always equal to a 1. Are we together? And every time you get log 1 of any base, that one is always a 0. Right now, you press your calculators. Press your calculators and put in log 1. Just put in log 1. You're going to get 0. Because the calculator will not even mind about which base it's having. The mere fact that you've pressed log 1, you get a 0, no matter the base. Are we together? Now let me ask you a simple question. To which base are those calculators you're having? What do you think? Those calculators are to which base? Do you know the base to which the calculators are? I'm just saying this. You tell me in the chat. To which base are those calculators? Do you know the base? Someone is saying no. Do you really know the base? The people are writing it in the chat. Do you see the role of interacting? People are knowledgeable. It is base 10. Now, this is it. If you know that the calculators are to base 10, assume that this one, okay, it's base 10. Now, let's make our number also 10. Now, you press your calculators and put in log 10. When you put in log 10, remember now the calculator is already to base 10. Though it doesn't give you the chance to press the base because it is already automatically to base what? To base 10. Now, when you press log 10, you're supposed to get 1. And you can also test it and see. So log 1, you're getting 0. Log 10, because the calculator is to base 10, you're getting a 1. Think you're understanding. So I'm going to ask you these things after here. Let me hope you're not going to be confused. So this one will turn into log a of a being 1. Then this one will be log 1 of any base. It is automatically a 0. But all these ones are coming from conversions. That's why I told you that if at all you miss anything in logarithms, you may end up missing the whole topic. So I told you that intentionally. Hope you're now realizing that now things are working. Okay? So, these are things that I want you to note. One is that the calculator is always to base 10. Then second, the moment they don't attach a base to anything, you take it to be log base what? Base 10. So note, 1. The calculator, the abbreviator as the calc is always to log base 10. So for you, just insert the number that is always the calculator. Then the other note, if they write for you something like log of x, it is the same. It is the same as log x to the base 10. So this one is what? Automatic. I don't know whether we are together there. It's like telling you in math that when they tell you x, it is the same as 1x. We have just decided not to put the 1. So it's like logs. When they say log of x, it's log x of 10. They have just decided not to put the 10. But for you, just treat it as what? As a 10. So concerning the natural log, I'm not going to teach it to you right now because I already taught it. After this lesson, I'm going to put for you a certain lesson that revises these things using a scenario. And I want you to watch it also, but I will not post it on YouTube because it is a premium class. And currently, classes are free. So I can't put it on YouTube and then later remove it. Is it okay? Now we are done with the major rules. We have others. We have what we call the reciprocal. We have what we call the change of base. But before I go to those ones, we are going to first do some numbers so that people can pick before we go into the other real questions because we are just joking. Yeah, the real work hasn't been actually discussed. So let's put some numbers and try. So before other numbers, I'm going to put some values for people to tell me what exactly they are getting. Just to check if people have mastered. So whatever I'm going to put here, I'm just checking you. So these are checks. Yeah. So when you pass all, just know you're good to go. So we're having log 2 plus log 3. So log 2 of 5, log 3 of 5. I want someone who is ready to give me all of them. Okay, this is what we are going to do. You're going to send answers that have all, you're going to send a message that has answers for all the 5 that I'm going to put. Are we together? So way to panic. No, so this one is going to be, so this one is log 20 minus log 4. Your answer should have both the number and the base. Then after that, you handle log. Mhm. Let me not make your life hard. So you'll be preparing the answers, eh? Okay. Then you also tell me, yes, you're A-level students, but the assignments that you really need. So this one is log 1. This is log 1 of 2. Yes. Now I want someone, you either raise up your hand, you tell me all, don't tell me some, you're telling me all of them. Now these ones are the ones that are more complex. So someone should also be preparing to take us through the ones that are more complex. When you pass the ones that are more complex, you know math. So I think let me choose Terry. So when Terry gives us the answers, I don't know whether people have sent answers to all in the chat. Let me try to see if someone has sent the overall message. Why I'm calling them more complex, it's because they have some thinking. And when you rectify that thinking, you're just good. With complex ones, I just want you to tell me the final answer. I don't want you to take me through the steps. I don't want. Where are we? Terry, I'm asking you to unmute. You're not. Okay, I think Terry is not ready. Let's go with Matthew. So Matthew, raise up your hand. You tell us the answers to all. Then people just
Yes.
confirm that the answers are similar. The first one,
The first one. The first one is log 6
log what?
5. Log 6 of 5.
Yeah, because you're going to say log 5, then you're going to multiply it 1 3, isn't it?
Yes.
You're going to get log 6 of 5. Okay, that is good. Then the answer to this,
The second one is log 5 of 10. Okay,
log
log
5
5.
of 10. Yes, log 5 of 10 or just log 5. Where you're going to get 20 over 4, not so?
Yes.
And then the third,
The third is log 0.93.
no, you first tell me what to do.
You put of 2 and then you multiply it by 3.
That is wrong. You see, you have forgotten. When this theory is to go back, that's what they call reversing a law. It goes back as a power. Remember, for it to sit there, it is at first a power, then it sits there. So if it is to go back, it still goes back as a power. You see? You wanted to lie to me by giving me a final value. So it is 2 power 3, which is log 8. Is it okay?
Yeah.
Then this one, log 4 4.
Is 1.
Yeah, because the number or the integer is similar to the base, so it is 1. That is correct. Then the last one,
Is 0. Log 0.
0. Because what? You tell me the reason.
It's because that this log of 1
Yes, and log of 1 to any base is what?
is 0.
Is 0. Thank you so much. So I want someone who is going now to take us through the more complex ones. Who is ready? The person called. Do I have anyone ready to take us through the more complex ones? Okay, let me choose Lina. I think Lina was the first. Okay, Lina, can you take us those ones?
I just give the answer.
Yes, I want the answer only. Yes, Lina? Lina, you're quiet. She's quiet. She's quiet. See people disappearing. Yes, Derek.
Okay. For this one answer is
Yes?
the first one, the answer is 1.
Okay, Derek is telling us the first answer is 1, which is right. So the question is how? So when you get this theory, remember it's supposed to go back as a power. So it comes here, 2 to power 3. So when it comes, that means it's going to disappear here. But remember, 2 to power 3 is 8. So let me also remove 2 to power 3, and I put there what? 8. So that's how they are getting 1. So I believe you had copied them already and you're following to also have your solution. All of you write for me the answer in the chat of the second one. What is the answer of the second complex one? Someone is like, all of the answers are ones. That is wrong. Me, I get one on all the more complex ones. That is wrong. The second one, the answer is 1, and that is right. So the question may be how? So remember, this one is a negative, but in actual sense, it is a negative 1, though we just don't show the 1. But remember, even this a quarter we are having already. Okay, this negative 1 is supposed to come here as a power. So it will be a quarter power negative 1. Isn't it? A quarter power negative what? Negative 1. So someone may ask, how do you really deal with that? I remember telling you that you can remove this negative. But when you remove the negative, here inside we shall take the reciprocal. What has been a quarter becomes 4 over 1, which is just 4. So you remain with 4 power 1, which is just 4. You were joking. So this one just becomes what? 4. And then you also obtain a 1. You're going to come across all these things when we begin calculating. Okay? Yeah? Even when you press the calculators, you see them helping you. So this last one, what are you getting on the last one? 0. So the last one, you first handle these two. Are you seeing these two? They were added, same base 10. So you multiply 3 and 2, you get log 6. So these ones, I'm going to remove them and say that they are giving us log what? Log 6. So log 6 minus log 6 is 0. Why do you even need to apply logarithms? Like why? It is log 6 minus log 6. It is a 0 without even applying logarithms. But if you feel like you want to apply logarithms, okay, log 6 minus log 6 is like 6 minus 6. Log 6. 6 dogs minus 6 dogs. Like no need, logically. But if you want to apply logarithms, you will have to say log 6 divided by 6. Then you end up getting log 1. Then log 1 will take us to the 0. Something like that. Hope we are together. Now those are the things we are going to really come across. But you need to appreciate the basics before you can even go into the other harder stuffs. So the first number we are going to do is a unib number. Yeah? It is a unib number. I don't know why someone called, but you don't want to use your real names. Someone who is using Tekken, I've asked you to unmute. Your hand has been up for some good time. I don't know if we are just trying to check on Zoom features and you forgot to lower it, but I doubt whether you really have something to say. Okay. Now, before we even look at other rules, because people may burst, only 2 are remaining and they are very harsh. Let us first try our very first number. So, we are now going to go to hands-on. So, this number is a unib number. In my notebook, I didn't note the year. I've forgotten, but I think it is 2016. Yeah, 2016, 2017. They are there. The question was saying, show that. So there are more 2 serious laws of logarithms that are mostly applied in most numbers. So you need to understand that whatever we are going to handle before them is obvious. If it's not obvious to you, then it's quite absurd. So it is 2 log 4 plus a half log, this is 25, minus log 20. So they said that, show that the whole of that is the same as 2 log 2. Unib number. Yeah. They gave you the whole of this plus this minus this. Then they told you, please and please show that the whole of that is 2 log 2. That's what they said. So they now want you to apply whatever you know on the left and make sure you reach the right. So how do you attempt these numbers of show that? I beg you begin from the left and make sure that you end with the right. Then you conclude like that. So you're going to come and say that what is your left hand side having? It'd be like my left hand side is equivalent to 2 log 4 plus, before you even apply whatever you want to apply, log 25. So deep down you know it is log 10 as the base, but don't include it. After all, even in what you're obtaining, it's not a must. But deep down you should know it is log what? Log 10. Now let us proceed. So it is very hard to apply laws of logarithms if at all you have something outside like this. So I always advise these things, always bring them like that. But here it is just log 20 as log 20. So for it is no problem. So as you're proceeding here, you're going to come and say log 4, but then the 4 now will be to power 2 plus. Are we together? Then you're going to have log, okay? You're going to have 25, then the power half. But I believe whoever is here knows that power half is the same as square root, if I'm not mistaken. So if you're a good mathematician, you can just come and put there what? Square root. Are we together? So that you save some time. But you can put there power half. Remember, when you put there power half, you're supposed to first rewrite the 25 as 5 squared so that their half can cancel with this 2 to get 5. But if you put there square root, you easily get the 5. So you can first put here what? The mistake you shouldn't do is putting there just log 5. There you will fail because you will not have applied the rule. Hope we are together. So this is root of 25, then minus log 20. That one is just like that. Now when you reach this step, now you apply. You apply all the rules at once. And no one will cancel your work. You can decide to do it in bits if you want, but you can just have your work at once. Yes. What do I mean? Someone is like, at once? What are you trying to mean? Someone may be like, let me use board mass. I first do addition alone, then subtraction later. But then you can decide to do everything at once. You know what people prefer? Do people prefer board mass or at once? This is what I mean by at once. That you write the logarithm like that, then you open brackets. After opening brackets, you'll be like, here they added. Because they added, I'm supposed to multiply those two. So you come and say 4 squared times the root of 25, sorry. Then you'll be like, here they what? They subtracted, so I'm supposed to divide by that 20. That's what I mean by once, at once. But then if you want to deal with board mass, you first deal with addition alone and keep subtracting, then you divide later. Are people okay with that at once? Tell me in the chat. I just need 10 representatives to tell me that the at once is very okay. Remember, the numbers get complex and complex as we proceed. So these cheap ones should make sense, so that in the future we are together. Yeah, it's no problem. Now you press the calculators and tell me what you're getting. What are you getting when you put it in the calculator? Put in 4 squared, which is 16, times root of 25, which is 5, divide by 20. What do you get when you press your calculators? You're getting 4 log 4. So you come and be like, oh, I'm getting log of 4. But then when you look at what the question said show that it is equivalent to 2 log 2. So you ask yourself, how can really log 4 become 2 log 2? How can it become 2 log 2? Very cheap. That's why I told you that these two work hand in hand. If you want to make log 4 2 log 2, it is clear. First write 4 in terms of 2. And 4 in terms of 2 is 2 to power what? 2 to power 2. Then you simply bring these two here. Then you get 2 log 2. Then you put here as what? As required. But remember, this was on the right hand side. So you tell the examiner which is equivalent to the right hand side. And that is enough. You have proved it, you have showed them. So don't you see that logarithms are not even hard? That is a UNEB number. It was 5 marks section A. Do you see? Very cheap. Should we go to question 2? I told you that if at all, when I ask something about whether we should proceed or not, if you confirm that we should proceed, you just write letter P in the chat. You just write letter P, 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 which means proceed, 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 proceed. Okay. Now we are going to have question 2. Remember, we are not using a calculator anywhere. We are just using the knowledge we know to do some numbers. So let's do another question. I know that people have question banks, but I think when I state the UNEB number, it will give people a time. Let's now do everything. We are also simplifying. So there are questions. I told you there are questions that we always tell you the destination. Then there are those that won't tell you. Those that tell you that just simplify and they stop there. You also need to be careful with those questions. Okay? Now we go. So they are telling you to simplify. Of course, don't use any calculator, don't use any tables. And it is log x. Then they are adding on this number looks hard. You see? Now they are telling you to simplify. But what I know about this number, that's how they usually look. The number can be scaring, yet it is literally nothing. But for you just need to calm down, do the math, and then leave the rest to yourself. So they are telling you to simplify such a thing. So as I told you, it is always very hard to apply the other rules of logarithms when we still have these coefficients, these ones. So always do your best and bring them, always do your best and bring them like that. Okay, now, what do we have? So here they are not telling you to show. So there is nothing like left and right. So you just write equal signs and just start calculating. So a good mathematician can first try to collect like terms, okay, before even doing anything. You can first rewrite. As you collect like terms, bring the x's together. You can first do that. So here I'm having x squared. Here I'm having this 25. Then here I'm having the half. Someone is writing in my screen. I don't know if you can tell me their name. If you can tell me the names of the people writing the screen, I remove them so that they serve as examples to the rest. Okay, let's proceed. Now, after collecting like terms, I advise you to now start on the transfer. What do I mean by transfer? Carry this to the other side. Okay, carry this half the other side. So what are you going to come up with? You're going to have log x. This one is going to be squared. Minus. This one is already very secure. So you just have this as squared minus 25. Then this one is going to be log power half. We agreed it is root. Someone may be like, but root of a number is a positive or negative. But you all know logarithm cannot be, okay, we cannot have logarithm of a negative number. That is very bad. Okay, now use a calculator. The root of 1600 is 40. I know the paper where that figure is 1600. That's how you read it when you reach medical school and even in other countries. just because in Uganda, I don't know why we read it as over 1.6k, but 1600, 2500, because it is right grammatically. Okay, now after having something like that, I told you it is always nice if you apply these rules at once or all together. Is it okay? Now, before you panic, you can first try to use body mass. Body mass. You see, we collected like terms, but again, we need to apply rules of logarithms in the end. I don't know whether people are getting me, but then there is what they call body mass. I think body mass can even work. Okay. You see, this mathematics is very rich. Let us use body mass and apply it at once. So I'm going to come and say this is log x squared. I'm supposed to add the first. So I bring the other log 40 because I've pressed my calculator. And then I subtract this one, which is my log. This minus 25. I don't know whether we are together. I just want now to use body mass. After that, I'm going to apply the rules of logarithms. Then I'm going to come and write my log, the single one. Then I be like, x squared is supposed to multiply 40. That is 1. Then it is supposed to divide. Now this is where things become tough. Or this is where I call you a poor mathematician. I remember telling you that the moment you use curved brackets twice, convert now this bigger one into a square bracket. It's not wrong to have two curved brackets, but show that you were once a student of Sun Scholars Academy by having organized work. So we are after supposed to divide by this, but I don't know whether people are aware that if at all we divide by the other x squared over 25, it is the same as times 25 over x squared. Do people know that? That divided by this, it is the same as times 25, then out of the x squared alone. Do people appreciate that math? Let me check the chat and see. Do people get that math? Let me hear from Magdalene. Magdalene is my friend from, let me recall the school. Yes, Magdalene, tell us.
Wait, teacher, I'm having
Mm.
a problem with the math you just talked about. That thing of getting the x squared divided by 25 and then you put it on the numerators. Wait, what is that?
Yeah, okay, let me do that. But I think you're my friend from Tricona, isn't it?
Yes.
Yeah, I have a good memory. Okay, this is what I'm doing. Hope you don't mute yourself. This is what I'm saying. If you're having something like
Mm-hmm.
2 divided by 3 over 4, it's what we are talking about, not so?
Yes.
This one becomes 2 divided by 3 over 4, not so?
Yes.
Then this one is the same as times 4 over 3 times the reciprocal. It's what I've done.
Oh,
You
okay,
understand?
thank you.
So
Yes,
I got
teacher.
this x squared, I multiplied it by 40 because of laws of logarithm. Now I had to
Mm.
divide by x squared over 25. So to multiply, I must multiply by the reciprocal of this, which is 25 over x squared. Together?
Oh, yes, teacher.
Yes, doctor, not teacher. I'm not a teacher. I'm a tutor. A tutor and a teacher are different. Okay? Now, I'm a doctor. The mere fact I'm even teaching you from Mulago Paramedical School, that means I'm a pure doctor. Yeah? Okay. Those who are around paramedical school, you can always pass by and say hi. Okay? Now, do you realize that the x squared is cancelling? So 40 times 25, that is 1,000. Okay? Remember they say it simplify. So what are you getting here? You're getting logarithm over 1,000. But remember, deep down, you know this is a what? Power 10. Sorry, base 10, sorry. So since this one is base 10, as a mathematician who is really a best friend to simplified work, you should always try your level best to rewrite this one in maybe terms of base 10. Are we together? Because it is already base 10. And you're having 1,000. So to really simplify, don't you think if you rewrite 1,000 in terms of 10, something can be done? Yes, it can. And that is unnegotiable. Unnegotiable. It is extremely clear. So this one will have to become, of course, everyone knows that 1,000 is the same as 10 power 3, isn't it? I remember telling you to capture the cubes of 1 to 12, and 1,000 is the cube of 10. So, is that really my fault? So when that 3 goes there, what are you going to get after? The 3 is going to come, then you're going to have log 10 of 10. Are we together? But everyone knows that log 10 of 10 is 1. So that means it is 3 times 1. Then we shall end up getting a 3. Do you see? So we say that logarithms are very hard, very cheap. So when you look at a chi number, you may first get scared because of how the chi number looks like. But you have the rules. Do you see what I meant? That logarithms always, you can find a number having almost everything. This number has addition, it has subtraction, it has the power rule, it has the other one of 10 of 10. You see? That's what really makes them hard. That in the same number, you can find yourself applying everything. So that is it. Do I really need to repeat for anyone? Or we can go to the next number. Should we go to the next number? Okay. Now, someone tagged me. I don't know for what reason. Okay. So wait for the other two laws. They are the ones that UNEB usually brings, but they also turn out to be hard if at all you don't give these cheap ones time. Okay? So let's do some evaluation. Yeah? And then we see also how it really progresses. You see? And with your curriculum, don't be so worried about those numbers to do with proofs. You see, proofs don't end. Let me tell you, even if we have a class where we are going to handle over 1,000 proofs, they can give you a proof and you fail. I see students flooding my inbox with numbers of proofs. I see them struggling, but when you advise them, they don't want to listen. You see, proofs are so many, they shouldn't waste a lot of your time. Yeah. For you just do them in groups. When it comes out, you leave it there. After all, it will not come back. It's only the physics students that are supposed to revise derivations. And derivations are different from proofs. A proof is something I can set on my own. A proof is something that even AI can set. So that thing is very weird. But a derivation that is already known, AI cannot give us something new. So you just need to be careful with certain things. So let's see such a number. So they can tell you to evaluate the log of 216 of 6, then plus the logarithm of 64 of 2, okay, then out of, we are having the logarithm of, I think I've copied a wrong question, but okay, it's okay. This is math, no problem. Logarithm of 243 of 3, okay. Then we can have the logarithm of 0.1 to the base 10, like that. Then they have told you to evaluate. Yes, that's how questions are set. Evaluate. You look at a number, the bases are not the same, you even get confused of what you're really going to do. But you really need to think so much as a student, the mere fact that the bases are different, so you're going to handle each logarithm on its own. Always first ask yourself, can I write this 216 in terms of 6? Can I write 64 in terms of 2? Can I write 0.1 in terms of 10? Can I write 243 in terms of 3? Always first ask yourself that question in logarithms. Always first ask yourself that. Why that one is always preferred? Because the moment they look the moment this one looks like this is a 1, so you will have simplified your work. Someone will be like, why? Why should I really force this one to look like 6? Because the moment by default it becomes 6 and 6, maybe with the power n is going to go this side. I remain with n log 6 of 6, which is going to reduce to n. Haven't I simplified work? I have. So always force yourself to make sure that the integer and the base are the same, especially when you're simplifying. If it refuses, that means you've not reasoned the question out. That simply means you're supposed to try out something else that you've not realized. Do you remember when I told you to master the cubes of 1 to 12? So you should be knowing that when you have 5 power 3, it is 125. When you have 6 power 3, it is 216. These ones of 2, you should know them from 2 power 1 to 2 power 12. You should know all of them. So that when they put for you 64, you know 64 is to 2 power 6. 128 is 2 power 7. Things like that. 32 is 2 power 5. 16 is 2 power 4. 3 power 4 is 81. They are those you should know at head. They will always simplify your work in these topics. Hope we are together. This one, 243. This one was there even in the lessons of indices, and everyone by now, I believe they know that is 3 power 5. Is that really hard? Not hard at all. 0.1, everyone knows it. It is 1 over 10, and 1 over 10 is 10 power negative 1. So you have written 0.1 in terms of 10. That number gets simplified. Logarithms are not hard. It is you who tries to attempt them with that feeling that they are actually hard. You give them the aura they don't have. Okay? Now, I'm going to come and say, this one is log 6 power 3, then 6. Then I come and add. The other side, I'm having 64. So I'm going to come and say, log 64 is 2 power 6. Then the base is 2. Let me tell you, the students who are serious, those who are going to join medical school and engineering school, they are done with the answer. Just because I've tried to check the chat and no one has sent the answer yet. Yes, someone has finally sent it. And I don't know whether it's right, but we are going to check. Okay? But these are cheap things. Then down, you're having 3 power 5, then the other 0.1 is 10 power negative 1. Okay? Now, that person who has sent the answer, trust me, we are wasting their time. The moment I give you an idea, you start attempting. That's why I tell you to come to the class. That's why I tell you to come to the class with a book and a pen so that you just write. Okay? Then when I drop the powers, some of you have a tendency of, now you just come here and write a theory because you know what is remaining is log 6 of 6 and it is 1. You will fail. You're supposed to rewrite all this work. It is necessary. This is 6. This is log 2 of 2. Then down, you have 5. You rewrite log 3 of 3. So this time round, it is a negative 1 that is dropping. So when it finds this negative, it will become a positive. You get? Then you're going to remain with log 10 of 10. Yeah? Like that. Is that hard? Okay. Then we begin. Log 6 of 6 is 1. Okay? Log 2 of 2 is 1. You show it. Be organized. Log 3 of 3 is a 1. Log 10 of 10 is what? Is a 1. Then when you have such a step, you can now jump to the final answer straight away. other than you missing important steps and then you delay to reach the final answer. Have relevant ones, jump the irrelevant. So the relevant is showing the log 3 of 3. The relevant is showing how you replace them with the 1. Then the irrelevant is how you simplify it to the final answer. Are we together, people? So what do we have? We have 9 over 6, which reduces to 3 over 2, that finally becomes 1.5. So I request that after that you say that therefore you come and rewrite the question. So come and say log of 216 of 6 plus, it was I think log 2 of 64. Sorry, log 64 of 2. Then what do you have down? You're having log. Could you try again? You're having log 2 for 3 of 3. Then I think minus 0.1 of 10. Like that. And then we have said this one becomes 3 over 2. Yes, you can have your answer as a fraction. Or someone may prefer 1.5. It is also okay. But leaving your answer as 9 over 6 is not okay. It's not at all. It's not okay, and I don't really advise it. So the other numbers that really fall under what we have covered, they are easy. You can even set numbers on your own. There are too many, they don't even end. But I want us to look at some of the numbers. I think the rest of the numbers you can really try, people. I'm going to give you numbers, a certain assignment, but I even taught you the difference of two squares. I taught you the difference of two squares. You don't really see some numbers as really worth being done here. Let me put for you some numbers I see people can do. Assignment. So the moment you people tell me that they are doable, I'm going to stop there. Simplify, because the actual numbers, it's the other two rules I'm telling you about, and I don't want us to really miss them. Okay, so simplify. The first one is this. I want you to just look at it and tell me if you can really do the number. You look at it and be like, maybe I'm going to give you hints. And you all know it, the moment I give you hints and you don't try out, you'll have wasted time. So I have here half, I have here log, then I have x squared minus 1. That is 1. So look at it and tell me if it is really doable. If they are doable, then we are going to do other things. Remember, we are simplifying. So this is, here we are having you tell me, can you do those numbers? Do you think you can do those numbers? You look at them well. Look at them well. Okay, let's begin with the first one. The first one is A. I want to first give you the chance. Don't say no because you want me to do them, because they look hard. Those numbers are cheaper than the ones I've been doing, but I want you to look at them very well. These are things I want people to realize. These are things I want people to realize. Can people realize that this is a difference of two squares? And can people realize that the moment you bring this a half and you put it here, there is a way it will resemble this, and then this is added. Can they really just multiply everything and do the algebra? You understand? Now look at such a number. This is the same base, base A. Can't you really multiply this and this? Deal with A. Can people see the A becoming A power 4? Can people see the Y becoming power 0? Do people see the Y disappearing? Do people see us getting a certain power? Do people see the answer as 4? Those are the things I want people to see. Do I really need to do those numbers? Now, the last one, it's not even worth it. I don't really. Do I really need to do the last one? Let me get genuine comments from the chat. They are cheap. You people, number 2. Now, the second one is even cheaper than the first one. People, I think they are cheap. Should we now? I think we should just go and let me just brief you very fast. You're going to see that things are doable. This last one, this is base A and this is base A, and this is addition. So it's supposed to multiply this and this. When you multiply A squared and A squared, you get A power 4. You understand? When you multiply Y power 3 and Y power negative 3, you get Y power 0, which is 1, so Y disappears. Then this car 4 will go the other side, you get 4 log A of A. Then you get 4, because log A of A is 1. Do you see that that one is even cheap? That one is cheap. But now this first one is my worry. But this first one is also very cheap. If at all realize that carrying this I have this side, we'll put here a root. And then this one will become difference of two squares, x plus 1, x minus 1. And do people realize that the moment you multiply them because of this plus, this one will cancel with this? This number is cheap. This number is cheap. This number is cheap. Just because people have not studied SADs, but let me try to make it simpler. A people aware, let me remove this sign. Let me remove this. Let me remove this sign. Are people aware that that thing is the same as this? Remember, it was overall, yeah? Are people aware it's the same as the top having its root, even the denominator having its root? Are people aware or they didn't know? Were you aware of that? So after being aware of that, I believe now the number you can do. If you can transfer this half this side, you put a root. The rest is your algebra. Because of plus, you multiply. You just see things doing themselves automatically. So I think that is all. So let's now go to solving. We have simplified. Now let's go and solve. So solving is going to be very cheap. I'm going to do a few numbers. I'm going to do a few numbers like 2. Then I give you 2 numbers. Then I think we go to something else. We go to the other rows. Yeah, because they're the ones that have serious numbers. Here we are joking. We have not started the real logarithms. And I wanted us to begin them at 10:30. 10:30. 10:30. I'm seeing we are running out of time. So let's look at these cheap numbers. Okay? Now equations. Equations. Equation. So the equations we are going to first look at, because I'm saying they are very cheap, for them they are going to be having similar base. See? They're going to be having similar base. Let's do them chap. If by 10:30 we are done, that is good. 10:30 we begin the other two. By 10:45 we have introduced them, we start applying them. Before midnight the class is done. Then I leave you to go. Give you a lot of research numbers. A lot of them. a lot of them. So what is the cheat code of logarithms? And we are dealing with the same base. I remember giving you the rule of equality in indices. So here it's the same thing. That when you're having log A of B, even this side, when maybe you're having log C of B, do you see this? Because now of this, you're having the same log and the base on both sides. You see that? Because of that, now A is equal to C. That is the rule. So I will just come here and say hence A is equal to C. Are we together? Because log A of B is equal to log C of B. Because of that, log B on both sides, A will simply be equal to what? Is that hard? Someone may ask, is it also the same as bases? Yes, it is the same to bases also. The same to bases, it doesn't change. Yeah? So it also applies to bases. That if at all you're having something like maybe log A of B like that, then this side you're having log A of C. For you just look at what is similar. So do you see that we are having this as similar, having this similar. So that means even this B and C, there is something in common. So I also come and say, hence B is equal to C. And that's the cheap thing we are going to be using in whatever we are going to apply. Okay, now the very first question. And these are things that are too rare. Okay, now, first question. I think I should also get numbers, though I wanted us to go through our workbook in the end, but it is okay. We're going to get some few numbers from here and see, but they are very cheap, very cheap. These are suds, logarithms, all those are rules. We're also going to try out those numbers. This book of mine is not serious. Okay, let me use my notebook. Okay, now they can give you such a number. Of course, solving for x. They tell you solve for x. And then they tell you that given that, they give you log x of 3, then they say this one is equal to, they give you a 2 log of 3. Do you see that? Minus, this is log 5 of 3, then plus log 9 of 3, like that. Then they tell you to solve for x in such a thing. So the very first thing you appreciate is having a common base. You're having 3, 3, 3, and 3. When you see that, you just even thank God. Because now, what is that? Very cheap. I don't even need to do a lot of things here. Because now, guess what? You all know this one should go on top here. Who doesn't know that? Everyone knows that. So what do I beg you? Have this, you maintain this log 3x. Then after, you come and do the overall bracket we have been doing. And let me tell you, even if you don't first rearrange, but of course I advise you to rearrange first. But let me tell you something. What may happen if you don't rearrange? But rearranging is better. People may get me wrongly. So rearranging, first add this one. So first add the one of 9, you get, and if by following. Then now subtract the one of 5. Do people notice the change? It was minus log 5 plus log 9. Now I've changed it to plus log 9 minus log 5 so that you follow board mass. Yeah? Now after rearranging like that, now you do the other thing. You be like squared. I'm jumping a lot of steps, but I'm giving you the ideas. I believe you can write that math as we've been doing before in evaluations, okay? So it'd be like times 9, then over the what? Over the 5. That one. Yes. Can people do that? Don't forget the base what? Base 3, because it is common throughout. So what do you get? What do you get here? Someone tell me. What do you get when you say 4 squared? That is 16 times 9. You tell me in the chat. What are you getting? Someone saying 28.8. Let me trust them. Okay, that is it. Now you realize you're having log on both sides. It is the same base. Do you see this? Log on both sides, and it is the same base, what? 3. So x is 28.8. You people is solving really hard. Very cheap. When you see same base, just thank God. Okay? Now let me show you this one also, the next example. That one you have no choice. You cannot tell me you've not understood. When I don't ask whether something has been gotten, I just believe it is too obvious not to be gotten. So another one can give you something like this. Give you this one as log x. Then they put for here 6 minus x. Then they put here for you equal to 2, something like that. So someone may ask, where are the similar bases here? Here, no need of similar bases. Convert that logarithm into an index, or the index form. You all know this one is the what? This one is the base. This one is the base. And to make your life easier, it is always the base, power this, then you get this. This is how we are moving. You all know this one is the power, isn't it? You remember the relationship. So it is always this one, power this, equal to that. So what do you get? You be having the x squared being equal to this. Arrange it quadratically. What will you get? X squared plus x minus 6 equal to 0. Do I really need to solve that? I don't. People know how to use bulldozer. I taught people factorization method. I told people how to get the factors and to use them. Maybe I can help you with the sum. So in that one, the sum is what? The sum is 1. Then you can see the product is what? The product is 6. However, I saw people struggling with the product. People didn't get me when it came to the product. People didn't get me well. People didn't get me well, and it was quite absurd. That I'm going to brief you again. But let me tell you from here. Quadratic equations are in this format. We were told in O level. Ax squared plus bx equal to 0. The sum is this positive b. So if it is a negative, even the sum is a negative. If it is a positive, well and good. Are we together? The product is this a times this c. So why I only consider this negative 6, it's because here I'm having a 1. Are we together? It's because here I'm having a 1, just a 1. That's why I tell you the product is just negative 6. But if I had here a figure, maybe 2, then the product would be negative 12 because of 2 times negative 6. So get it from me that the sum is always the b, whether negative or positive. Then the product is always a times c, so I'll put a c, not just c. So as you're getting factors, you should put that in consideration. Because factors, we now need numbers which when added give you 1, which when multiplied give you negative 6. And I gave you the technique. That always just ask yourself, which numbers do I multiply to get 6? The first one is 1 times 6. Those ones cannot interact in any way to give me a 1. The others, it is 2 and 3. 2 and 3 can interact to give me a 1. How? By saying 3 minus 2. So that simply means that the factors, it is -2 and +3. And you know the factors replace the sum. So do I really need to waste my time there? Not really. Not really. So I'll go to the third question. I told you the moment we leave you behind, you ask. Okay? Question 3. So you people are going to give me the answer to this. I'm going to put there that these numbers are very cheap. Are very cheap. Let me put all of them. The remaining ones. This is +2. Then we have plus. This one is also log. So 8. This is x minus 2. And then this side, I'm having a 3. You people, what are you getting? What are people getting? By doing that number. I'm going to just leave some small space. But this one, you're taking it as assignment. This one, you're taking it as assignment. I just want people to see that things can be combined. Do you see this? Do you see this? It is log 8 and 8. And we are adding. So when you come and say that log 8, I want you to follow. I'm skipping a lot of steps. So because of this addition, you're supposed to multiply. You're supposed to multiply this and this. Do people see that that one is a difference of 2 squares? Because it's x plus 2 and x minus 2. So that means before it was the same as x squared minus 2 squared. Are people aware that x squared minus 2 squared is what gives you a product of x plus 2 and x minus 2? And are you aware that 2 squared is a 4? Hope I'm not taking anyone very fast. Then I equate to a 3. Then after you convert this one into an index. And I've told you how do you convert into an index? 8 power this 3 is this. That means that 8 power 3 is the same as x squared minus 4. Who can, even a primary kid can answer that. Hope we are together. Are you following? Very cheap thing. Okay? Now, you just use the calculator. Use the calculator, get the answer you get. This is square root. And you know we avoid negatives. The answer here should strictly be positive. You know what happens with negatives in logarithms? You can never get a negative log. So in most of the cases, check if the answer you are obtaining may end up giving you a negative log. Like for example here, even if you just get an answer as -1, the moment you put -1 here, are you seeing here? It will be log of -3, which does not exist. So you're supposed to tell the examiner that the x value of -1 is not true. Or you can tell them is invalid. Are we together? Those who have been with us, you know what I mean by invalid values, undefined values, and so on. Okay? Now, this is a number you're taking as assignment. And of course, you know, before we confirm that it is assignment, I should get around 10 people telling me that it is really doable. So we're having log. This one is 10. Then here we have x minus 1. Are we together? Plus this one is log also. This one is 10. Then this one is x plus 2. Then this side we are having 1. Do you see that? Can you people really do that as assignment? This time round we have nothing like, if we have nothing like difference of 2 squares, you're supposed to apply the rules. Because of log 10, you're supposed to write log 10. Because of this plus, you're supposed to multiply this and this. So you come and put it here. X minus 1, then also x plus 2. Then you equate to the 1. Then you convert it into an index. Who doesn't know that to convert this, you simply say 10 to the power 1 is equal to this? What does that mean? That means that the whole of this, that means the whole of that number is equal to 10 power 1. Can't you do that? I don't even need to really go beyond that. So those numbers are cheap if at all the base is the same. Things become weird if at all things are a bit changing. So I'm going to now give you another number of assignment, and then you go and struggle with it. Yeah? Then we go to the other rules, the reciprocal one and the one of change of bases. And when we do the reciprocal one and the one of change of bases, trust me, we shall be done. We shall be done. Okay. So that is it. That is it. Hope people have been taking screenshots, hope people have been writing. Okay. Now, the number that we are supposed to cover, and then we leave this place. Okay. So all those assignments I'm really stopping on top or via where you're supposed to complete them in your free time. So we are having that one minus, we are having log, this is A. Then we are having 5y minus 24. Then also this side we are having log, then we're having 4 of A. Yeah, do you see that that one is also doable? I told you that laws of logarithms are very hard to really do if at all you don't first make such transfers. You see? And guess what? When you make such a transfer, it becomes y squared. Here you're already having a minus. So I don't know if there is someone who is seeing something like this. This one becoming y squared out of the 5y minus 24. Then this side you're already having log of 4. This one is A, this one is A. So do you see that this one is common? This one is common. That means you're going to equate this one to 4. Is there anyone who cannot solve for that? Because you're going to just cross multiply, create a quadratic equation, deal with it. How to get factors, you know, someone from someone product. If you're a fan of bulldozer, use bulldozer. I think that is okay. Now, let us now start the real lesson, logarithm. We are even 4 minutes past time. Okay, let me hear from Nina. Yes, Magdalene. Yes, I like people ask questions. Don't people just keep quiet as if it is church. You're supposed to ask questions and make the lesson active. Yes,
So,
Magdalene.
Doctor, I've been
Yes.
having an issue. So on the previous numbers you've given us, I've been trying to work them out, especially the first number for simplify, the one for part A. I don't know. I've gotten log x squared out, log x squared. And at some point I also got one, so I don't know the real answer. I don't know how other people have done it even.
What did you get? What was your second answer?
One,
Then the other one?
log x squared.
Maybe you send me your solutions. I will look into them.
Okay, doctor.
Okay. Now, that's the reason as why you always have communities of scholars. So you're supposed to post your answer and then ask people how they try to do everything. Okay? So the real lesson is now going to begin. And that is about the reciprocal law You're supposed to practice a lot. The reciprocal law and the law of change of bases. I want you people to take a screenshot of this. Take a screenshot of that. Tell people in the group that the lesson has started. Tell them the actual lesson has started. Take a screenshot of that. Tell people in the groups you're in, even on your status, tell them the lesson has actually started. Whatever we have been doing has not been logarithms. Now, these are the real logarithms. Yes. Yeah. So they had logarithms you always hear people talking about. They are these ones. Yeah. They are these ones. They are these ones that we are going to do right now. Okay? Okay. To begin with, the first one, the reciprocal law. The reciprocal law. What does reciprocal law mean? You've all heard of that word, at least I believe. Whoever is on this class has heard of the word reciprocal before. I just believe I know it's not your first time. Okay? Hope I'm thinking right. Now, this is what I mean. That when you have log A of B, something like that, log A of B, reciprocal, you all know it means 1 out of. So 1 out of, the moment you have the log here. Are we together? The moment you introduce in the 1 out of these two switch positions, A goes where B has been, B goes where A has been. So it instead becomes 1 over log B of A. It is very cheap, it's not even hard. Very cheap, not hard. Okay? Iggy, I know I have my people who always get it better when we attach some examples. So I've not forgotten you, my people. Let's do it. This is what I mean. When they give you something like log 2 of 3, this one, the moment you bring in 1 out of, it's going to become, so the 2 and 3 change positions, it becomes 3 of 2 because of the 1 out of. Okay? When you're having log x of 4, the moment you bring in the 1 out of, it becomes log x and 4 switch positions, it becomes 4 of what? 4 of x. Is that really hard? Is that really hard? If at all it is just something like, let's bring others. You're having maybe something like 5 and the base is x squared. The moment you bring in 1 out of, it will become log x squared and 5 change position. So it becomes x squared of 5. Then lastly, you're having log of 8, just log of 8, and you need the reciprocal. We all know it will become log instead 10 of 8. Because deep down we know there is a silent base 10 here. So when they don't put it, but we need to apply reciprocal, the 10 now goes up. I really don't need to give you trials. I think that law for it is just clear. It is just clear. They give you any logarithm, they tell you to introduce a 1 out of, the other things switch positions and the denominator becomes something new. Hope we are together. Okay? Okay. Now, are we together, people? Are we still together? I want 5 people to tell me yes, we are. Because now we are going for the law of change of bases. The one that you name once because it is the most difficult. You people, you cannot say no over 10 times. You're one person, you're saying no. No, 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 no. It doesn't make sense to send all those no's. That means you've just come. If you have issues with network, you're not disciplined, you're saying no and you're not disciplined. Raise up your hand and ask. Saying a lot of no's in the chat cannot help. So now let's go to the law of change of bases. Now this one is what proves you as a student of logarithm. Law of change of bases. Law of change of bases. This is where even the actual lesson begins. Yep. It begins from there because they go hand in hand in most of the cases. So how does this one really work? So if you're having your log A of B, you're having your log A of B like that. This is what happens. I want you to listen. I'm going to just make the statements. Then for you, keep the math at head. So when you're having log A of B, this is what happens. You get log A. So A gets its own log. Are we together? Out of even B gets its own logarithm. Are we together? It has been log A of B. I want you to follow. I want you to follow. The moment you mess up, you're gone. We have been having log A of B, but then we want to bring the law of change of bases. So put log A on top and log B down. So both letters get their own logs, but we divide them. And then we bring a new base. So I'm going to first call this base C, this base C. So I'm going to call this C a new base. This one. I'm going to call it the new what? The new base. So why the law is called the change of bases is because of that new base we are bringing. But have it in mind, you don't just put that base there. There are things you follow for you to put it. But first understand that when you're having, another one, when you're having, let's say, log P of Q, are we together? You can literally have log P as P on top, then even down, you have log Q divided. Are we together? Then you bring a new base, R. By the mere fact on top we have base R, even down base R. I don't need to call it common. It is clear that it is a common one. Are we together? Then another one. You're having log X, Y, like that. And you want to apply that law. So have log X on top, have log Y down. Then bring in that new base. Put here Z, put here Z like that. I don't know whether we are together so far. Before we even go any further, is everything has been gotten? Should I proceed to tell you about the new base? Because at least there are things you should appreciate. Someone is writing in the screen, what is the name of? Thank you for removing it. So at least one thing you should appreciate, log A of B. So A is on top, so it also goes up. B is down, it also goes down. But they all go as numbers. Then we introduce a new common base. You're having log P of Q. So you first split them, but as numbers, as integers. Then you divide them. Then you introduce a new common what? Base. Log X of Y. First treat them as numbers, separate them as different logarithms by division. Then after, introduce a common base on both of them and a new one. So it is a new common base. Okay? New common what? New common base. Now, someone may be like, what do you really follow for you to have that base? What do you base on? For you to say, this is the base I'm going to choose. I want you to listen now. I want you to listen to the rules of the new common base. Rules or the characteristics of the new common base, because they are the ones that you really need, isn't it? The good thing, you know it is new, and you know it is what? Common. New common base. One thing you need to appreciate. One, sometimes the question tells us that new base. Sometimes the question does tell us that new base. Hope we are together. Then two. So how we are going to see the questions? If it doesn't, use the smallest common factor. Use the smallest common factor for each, for A and B. For case 1, I used copy and Q. I used equal for X and Y. I'm going to teach you that. Someone may be like, what do you mean by smallest? I believe people know what I mean by smallest. And I also believe people know what I mean by factor. You get? Then I believe the word common is just an English word. So I want people to tell me, of these two statements, which one is the right one? Then maybe people can get the meaning of the word. So I have two factors. This will show your primary school. So if you're not sure, please keep quiet. I have the first one, 2 is a factor of 8. Then I have the other one, that 2 is a multiple of 8. Which one is right? Factor, multiple. Which one is right? Factor, multiple. Thank you so much. It is factor. So 2 is a factor of 8. So multiple is not right. Someone said both. You're wrong. Multiple is something you multiply with something to get something. So 2 is a factor. So if factor is always smaller, the multiple is always bigger. So 8 is a multiple of 2. So 2 is a factor of 8. So I believe by factor you now get something. I told you mathematics is in 3 phases. There are people who understand this literature and can apply. Then there are people who understand when you mathematically express the literature. Then there are people who understand when you begin the actual examples. So since it is an academy for us, we do all. Then you choose what you really think is best for you. So we are going to do a lot of numbers. So please and please listen and listen. Okay? The first one. So we are going to do the first question. So assume you don't know whatever I've talked about. Then after this lesson, okay, assume the lesson ended 10 minutes back. Then after you be like, doctor covered for us logarithms. Let me do some numbers here. I see if I'm actually well off. Then you come across this number. Question 1. And the question asks you to evaluate. Of course, without using a calculator or tables. Then you find such a question telling you to evaluate. You find log. You find 9, base 9. Then you find 27 root 3. You find something like that. What do you really do? Yes, assuming the lesson ended 15 minutes back. Then you be like, let me do some questions of logs doctor taught. Then you find such a number. How are you really going to handle that thing? You cannot even convince me that you can really do it. Because even the calculator can't. Are we together? Now, this is what I told you. Even when you try the reciprocal law, it cannot work. Because even the base will become more weird. Are we together? But then you look at something like expressing it in terms of 3. Now, I'm talking to you as someone who doesn't know the law of change of bases yet. You understand? I even, those years I used to call it the law of or the law of introduction of a new base. But I respect the textbooks of math that call it the law of change of bases. But we are actually introducing a new base and we are separating what we found there by division. You get? So just assume whatever we talked about in the first time cannot help us do this. Even when someone overthinks and says, let me maybe express things in terms of 3. When you write your base as 3 power 2, now how are you going to continue from there? Imagine your base having a power. You're really making matters worse. So that's where the rule comes in. So you look at 9, you look at 27, you look at root 3. You look at all of them, they can really be written in terms of 3. All of them. Okay, they relate to 3 in one way or the other. For you, even if you don't concentrate on this root 3, the big values, it is 9 and 27. When you look at them, they really have a factor in common. Now, such a question does not tell you that factor, that new base you are going to introduce. It is not. Now, you're supposed to think and be like, 9 and 27, what is that smallest factor they have in common? And then the factor is a what? A 3. So you use that rule and you bring the 3. But you begin with the splitting. Eh? You come and say, okay, log. Okay, you come and put here the 27 root 3. Are we together? Then you come out of again the log. Then you put here what? 9. Are we together? Then you introduce the log. Sorry, the new base, which is 3. Put here 3, put here 3. The moment you do that, in all the curriculum, they put a tick here and a tick here. Because identifying that 3 yet the question didn't say it is actually top notch. So if at all there are excess marks anywhere and they are looking for where to add the marks, they can even come and add the 3rd and 4th mark. Because the moment you write that, you have passed. You have passed. That's what I can say. You have passed and there is no excuse. Because after that, the number is going to become very cheap. Why we make sure that this base we are putting is common to these ones is that in the end, we are going to write this one in terms of 3, even this one in terms of 3. And at some point, we shall create log 3 of 3, which will become a 1, and everything gets done. So you realize even with this thing I'm calling very hard, it's not actually hard. So logarithms are not hard. The hard logarithms are the other ones which have proofs. But why stress yourself with proofs that change every time? Have the concepts be in position to do basic numbers. You're safe. You're safe. UNEP doesn't bring those hard proofs. It is mocks that always want to prove up a point. But these cheap ones, these ones are also not cheap, but they are doable. But you find someone saying logarithms are hard because they found a certain proof. But ask yourself, can I really simplify simple things and do some evaluations? Good. And by the way, thank you for maintaining these big numbers. I didn't know that people can try to stay. Yeah, your friends got issues with data. They were stopped by parents, but for you, you're here. So also thank your parent for allowing you to study for long hours. Tell them that is A level. That's how everything runs. Yeah? They will be proud of you when you finally make it. Okay? Now you're going to come here and say, that one will become log 3. So 27, we agreed, you're now writing everything in terms of 3. 27 is 3 power 3. Then the other one is 3 power half the root 3. And so, then out of this one is 3. This one 3 power 2. Are we together? Then when you simplify, this one will be log. The cheap things. Log 3. So you all know when I get 3 plus 1 over 2, what do I get? Tell me in the chat. What do I get when I say 3 plus a half. What do I get? Now this is the mistake people do. This is the mistake people do, but the good thing I warned you, Anthony, stop putting stars in the screen. You're looking for attention and I will just remove you from the meeting. And you will not get what you were seeking. So better leave the screen. What is 3 plus a half in the chat? You people, you cannot add that using your head. No, you people, you cannot tell me 3.5. You be organized. Now how can we write 3.5? You be organized. How can we write 3.5 in indices? Are you being serious with your lives? And then someone is still writing 3.5. Thank you, Peter. 7/2. Peter, inbox me after this lesson. I'm going to give you free classes for senior 5 and senior 6. You will not pay anything for the 2 years. How can I ask you 3 plus a half and you tell me 3.5? You tell me 3.5 because you're lazy to use a calculator. 7/2. Then the mistake people do, you carry this 2 here. Are you seeing this 2? You carry it here. Yet you have not yet carried this one here. I told you always have the step where you're doing the same things. But now, in the numerator, you still have the power on top. In the denominator, you have dropped the power. What is that? So if you agree, you be patient with the numerator. If the numerator has not yet had the overall power and the denominator already has it, the denominator should wait. Should wait on the numerator and then you do things at once. So you first have the 2 here before you can have those fast things. Okay? So here, when you reach here, drop the 7/2. And I told you first keep the log 3 of 3. Okay? Then down, you can also now come and drop the 2 log 3 of 3. Now, for this case, you may not substitute for the log 3 of 3 as 1, as I said, because you have it on top and at the bottom. So it just cancels, okay? 7/2 divided by 2. Magdalene, hope you understand when I say it becomes 7/4. Because divided by 2 is the same as times a half. So 7/2 times a half is 7/4. Let me check if my friend Magdalene is on. Magdalene, if that is okay, you react with thumbs up or you raise up your hand and lower it if you get how 7/4 is coming. Okay. I think she got it. Okay. Now, you people, that is it. This is the thing that I've been calling very hard. Let me give you another one. Let me give you another one. Let me give you another one. Okay. 2. Now, how these things are proven, you don't need, because even the syllabus doesn't say that. It was the old curriculum. But they don't even usually say it. And it will be so hard to find such a question in the new curriculum because it is more of cram work than understanding, and competency doesn't involve you to overcram. But the proofs exist. And I'll give it to you as research. Go to YouTube, you're going to see those weights. It's hard to find a Ugandan who is going to derive them for you. Weights. So you see those weights of, those weights. They're the ones who have lessons on those things of deriving. You can't learn. Put it in your notebook. Just have it. Just have it. Utilize internet when you still can. Okay? Now, this is another one. This is another question. I don't know if people can pass it. Here is the question. Evaluate. I don't know, maybe you guys should do it. But I'm going to do it. I'm going to do it. Okay. And you people, those who are on, make sure you utilize the drive when it is still early, when you still have the time. Yeah, anytime they may switch it off because it is almost the deadline of free classes. And I wouldn't want my friends to really miss out, especially those who got to know about the free classes late. So log 8 of that time was Log 9 of 2. Now you look at such a question. How do you even start? You cannot press it in a calculator. They have told you don't use a calculator. And you like it or not, you're going to struggle. You're going to struggle. Yes, you're going to struggle. But how are you really going to do that? How are you really going to do that? How are you really going to do that? So for you, just don't worry. You just do it as it is. For now, you can first proceed because you really don't have any option. Because first and foremost, 9 and 2 don't have a common one. Because even if you force yourself, okay, they don't have anything in common. Even 8 and 3, they don't have anything in common. So you see how things may turn out to be very hard on your side. So that now this is what they call to just move with the flow. Now here, just move with the flow and see what the future has for you. That's one of the formats of math. I always say it in chemistry. When you're watching lessons of ionic equilibria, you will see it. I always tell chemistry students when they provide you with certain information, just use it the way it is. You get? And then find out what does the future hold for you. Okay. Now here I'm going to come and say, log. First do everything as it is. So you know that 8 is 2 power 3. Remember you are evaluating, and to evaluate you should simplify first. So first do. You don't even know why you are doing this, but for you do. You see what will come out. Then what are you getting? This one is becoming 3 log 2 of 3. Then this one is becoming 2 log 3 of 2. Do you see that? And then guess what? 3, this 3 times this 2 becomes a 6. Okay? Times
6 minutes and 2 seconds.
keep
Counting down.
quiet. Then you're going to have this first one, log 2 of 3, getting multiplied with log 3 of 2. Do you see why I've told you that in math, always when you're stuck, just do what you feel like you have to do. Then see what the future holds for you. I don't know who has seen what the future held for us. Do we have any way we can really deal with this? I want someone to unmute and speak. Don't write in the chat. I want someone who is really serious about their academics and they are really looking forward to making it. What do we really need to do there? Do you see anything? Okay, Derek. Yes, Derek. Unmute and speak. But your network is usually poor. I don't know why.
That's a very reciprocal.
Still, your network is poor. I don't know, people. Is it my network or it's his network? Every time he tries to speak, I don't hear anything. Okay, you just write the people have said it in the chat. It is reciprocal. Thank you so much. So the mere fact, the moment you realize that 2 and 3 in the two logarithms, they are trying to interchange positions, you think of the reciprocal law. So you come and apply it and be like, oh, that means I am going to have, this one is going to be, okay, just be like, here I have my log 2 of 3. Then maybe to have it as similar, this one I'm going to write it the reciprocal way. So this last one, when I bring in 1 out of, guess what? It's going to become log. It was 3 of 2, so it's going to become 2 of what? 2 of 3. And if you're a good mathematician, you can see things cancelling. But remember, I told you never show, never cancel work. Just tell us 6 times 1 and then come with the 6. I don't want you to be students who are going to use arrows in an exam. We are using arrows so that you people follow up. I'm a doctor, so I know that arrows are better than equal signs to make your mind sharp. Yeah, other than equal signs. So that's why in one lesson I can use arrows, some other lesson I use something else. Get the ideas. I always guide you on the flow of work. So hope that is clear. Do you see? that you need to just be doing everything the way it comes, then you wait and see what the future really has for you. Hope we are together, people. So now, so do you see that this number now was for the reciprocal law? Excuse me. Okay. Hope that is okay, people. These are numbers that they can tell you to evaluate and you sweat the whole day. This is where most students stop. I remember examining this in January to the Form 6s. Most of them were stopping here. They didn't really have a way forward. They didn't. So I've told you about proofs. Let proofs not disturb you. That's why even me, when I'm teaching this topic, I first teach you everything. Even indices had proofs, but I didn't talk about them. I want to first really confirm. I want to first see how the curriculum is going to be examined like for 5 years. Because these things are proving, they may even be wasting our time. Because I could wake up on some days and set over 10 proofs, over 10 from my head. And those are the questions that the curriculum is trying to avoid. We want something that is applicable, not something someone can think of and set for students. Something that really has applicability in it. Okay? So let's do some equation. Eh? Let's do some equation. Let's do some equation. Now, I believe with evaluations, simplifying, those ones you will handle. Let's do some equations. Yeah, and there are so many equations. Now, there are equations I want to end with. For them, they are cheap. They are like those of indices. They are just involving dividing. There is nothing so special about them at all. Okay? Now, how does the equation look like? The equation is log x squared of 3. So this is question 1. Of course, you'll know in the equations we are going to solve for what? We are going to solve for x. Okay. That is it. Then we shall put brackets. And then we are going to have log. Okay. Then 3. Then here we are going to have 9x. And then we shall have equal signs. Then we shall have this one like that. Are we together? Yeah, that's the question. They tell you to solve for x. Is that really hard? People have started disappearing, have been used to over 100 students. So make sure you tell them to come back because now the real work has started. Okay? Now when they give you such a number, realize that this one is set already. This one is set. This one is just okay. Unless otherwise. But when you look at this one is a bit not okay yet. Are we together? When you look at it, it's not yet okay. But we can do something about it and it becomes okay. Remember here, are you seeing this? Here 3 is down and here 3 is on top. The moment you see something like that, think about the reciprocal law. Straight away, think about the reciprocal law. Now you ask yourself, is it always better? People, you tell me, is it always better for the unknown to be, okay, is it good for the best to be unknown or it's not good? Okay, this is what I'm asking. First way to answer me. We are putting a weighing scale. This is the weighing scale. You're having 3 here and 3 here. That means when you apply reciprocal law here, you will have something like 1 out of log. 3 will be up, then our base will become x squared. So you're creating an unknown in the base. But when you leave this one as it is, so when you apply reciprocal law here, you'll be having 3's on top here. So unknowns will be in the base. But when you leave this one the way it is, and you apply reciprocal law here, you will have 1 out of, you will have log. So now 9x will be on top, or as the number, then 3 will come as the base. So which one do you really think is better? When the base is just left normal, or when we introduce an unknown in the base? Okay, which one do you really prefer? Do you prefer us doing this option 1 or this option 2? Which one do you really think is going to make our life easy? Both of them work, but there is always that one that is really going to make your work. Yes, it's better to leave the base normal. Otherwise, you're going to bring yourself problems. So option 2 will always win. So as you're doing these numbers, ask yourself, especially when you have options of making either, when the reciprocal law affects any of them. So now put things on a weighing scale. Try to see what may happen in the future and handle things appropriately and accordingly. This one is a UNEB number. Hope you are aware. But I told you, if at all we keep on reading numbers from the question bank, we may not leave this place. And I know people have not bought them yet. But next holiday, make sure when you come for a math class, you have a question bank. Okay? So we have agreed that we are applying reciprocal law here. So this one will become log. So we shall have 9x here, then 3 down like that, then equal to 1. So now you people, you know math. You know math. I'm not going to waste my time. I'm going to just carry this, put it the other side, because it is just multiplication. There is no addition or subtraction anyway. I'm going to just carry it the other side, so that here I remain with log, here 3, here we'll have x squared, then I will have equal sign, then I will have log, then I will have this one, then I will have 9 what? 9x. Is that hard? Then you recall, we talked about the cheat code of equality. The moment you have something like this, log 3 on both sides, this x squared is equal to 9x. Okay? Now, I want you to tell me, this is where we are as of now. Isn't it? That's where we are. That's where we are as of now. You tell me, what will a student who doesn't know math do? After this step, what will a student who doesn't know math do? You see, the students who don't know math are already answering in the chat, giving me wrong things. Giving me wrong things. I'm asking, what will a student who doesn't know math do at that step? Will get square root. That is wrong. Factorize 9. That is wrong. Root. That is wrong. They will introduce root. That is wrong. Divide by x. That is it. Thank you, Precious. Precious, you also inbox me. You also inbox me. I'm going to give you free classes for your entire A level. Cancelling out x. That's what a student who doesn't know math will do. I told you in the previous class of indices that put these things on one side. The moment you cancel any unknown, you are canceling a value you don't know. So you're bringing yourself issues. So always put things on one side, especially when they have something in common. You get? So that now after something like this, you can now put x out, get, then inside you remain with x minus what? 9, you equate to 0. So either you first write all values, see? So you first say either x equal to 0, all x minus 9 equal to 0, and then x will be what? 9. Are we together? But now, let's come and check. What is log of 0? Check log of 0 on the calculator. Put in log of 0. Because this x equal to 0, imagine we substitute it here. It will be 0 squared. So 0 squared of 3. But without considering 3, put log 0 in the calculator. What are you getting? You're getting math error. That means that value of x of equal to 0 is not right. You get? So you just simply come here and do this. Yeah, that is enough math. Just cross the equal signs. You understand? Yeah. Or you can first have it like that and then you come and bin it. And you say x can't be 0, therefore x is 9. So you have to come in the end and finalize with the final answer like that. To show them that the answer is 1. Let me hope people are getting. So let me hear from Anthony as people look at the whole solution. Then we go to another thing. So you see the Chinamba, it looked hard, but it is bogusly easy. Not hard at all. So for me, I'm not going to do any proofs today until further notice. Just imagine if at all we wake up one day and we say, science scholars, today is a Sunday, and in the afternoon we are going to do only proofs that involve indices and logarithms. We can complete. But as of now, first leave me. Let's first do cheap things. Yes, Anthony, you had something to say, but you're not speaking. Even
Doctor,
Stara. Yes.
as if before pressing the log 3 to log 9 to base 3, you just cancel the log 3. Could that work?
You cannot just cancel the log 3s. It only works in equality where you have them on both sides and they don't cancel. We just assume that when log 3 is on both sides, log base 3, the other numbers are equated. You cannot cancel them. For me, I don't believe in cancelling. You cannot just cancel them. No, don't even do that. First equate them so that the reality of equality comes in. Owulidde? Someone else had something to say, but they are quiet. That is Tara.
Doctor, sorry. Here on this second step, you say you take log 3 9x to the other side. I didn't get it. How did you do it? Where did this one on top go?
It remains that 1 times anything is that something. So that one does not affect whatever is remaining on the left-hand side.
I mean this one on top of the
Yes.
log.
Yes, it's like having a times 1 over b equal to 1. You simply get a is equal to b. That one has no effect on this a.
Okay. Thank you, Doctor.
Okay. Now I'm going to put a certain number also. We do it. So this rule is not so hard. It's not so hard. Yeah, it's not so hard. Let me put some number here. We give it a try. It's a cap proof, yeah, but the cap proof is cheap. It's a cap proof, but the cap proof is cheap. So I don't know which question is this, but I'll just put new question. I've forgotten the question number. So they are saying show that. Show that log x of 8 is 2 over 3 log this. Are we together? Now, this is where I want you to listen carefully. Here I want you to listen very well. Otherwise, you may mess up. Yeah? I told you something, and I don't want you to take it for granted. Yeah? So look here. Show that that one is that. Then they said, hence evaluate. Hence evaluate log 6 of 8. Okay. If log 3 of 4, if log 3 of 4 is equal to 0.7925, like that. That's the question. So this is what we are going to do this. You see that? Now, the moment you realize that this one is base 8 and where you're going it is base 4, that means a new base was introduced. You get? That's where the law of change of bases comes in. The moment you realize the change of base, the other one was realizing reciprocal. Now, this is all about realizing a new base. So just know the rule came in. So I told you a question will always tell you which base it wants. Are we together? If it doesn't, then you use the lowest common factor. You all know the lowest common factor of 8 is a 2. Are we together? But now where we are going, they don't need the 2, they need the 4. So you use 4 even when you know that the lowest common factor or the lowest factor of 8 is 2. But the question wants 4, so you're supposed to use 4 by force. So as you're solving this, so I'm going to come here and say, I'm solving. So as you're solving this, when you come and say log x of 8, because a new base came in, so you're supposed to use that rule or that law. You're supposed to come and say log x, are we together? Out of, then you also come and say log 8. Then you introduce the new base. The base that could be right is a 2 because it is the smallest. Because and we always want to simplify. But that's not what the question wants. The question wants a 4. So first introduce that 4 to be on a safe side. Because when you introduce that 4, now you have created what the question wants already. Now that means you're only having one battle, is converting this log 8 of 4 into this coefficient of 2 over 3. I don't know whether people are getting me. Now you start battling with the denominator only. Only. So now this one, you're going to handle it normally. Because now you have already what the question wants. You now have this, you should turn it into 2 over 3 in any way. So you start struggling. So you come and also work on it. You cannot use a calculator, my dear. You cannot use a calculator because they don't want you to use it. They told you sure. If they told you sure, then why are you using a calculator? It's not applicable. So you're supposed to come and say log 8. Then also down, you come and say log what? Log 4. Then bring the new base. So for this case, you're using the principles that 8 and 4 have the lowest common factors 2. So you put here 2, you put here what? Put here 2. Then you proceed. Come and say log 2, 8 is 2 power 3. Let me tell you, a serious student has already realized that the thing is coming out. Then 4 is 2 power 2. Then what are you getting here? You're getting 3 log 2 of 2. Then what are you getting down? You're getting still 2, then log 2 of 2. Very cheap things. Very cheap things. Then you come up with the 3 over 2. Magdalene. Let me see if she's here. Yes. So you're having 3 over 2. Now, this log 8 of 4, this one, is coming out as 3 over what? Over 2. You all know, if at all we are dividing this one by 3 over 2, we multiply it by 2 over 3. So, I don't know if we are together there, Magdalene. So you see your thing is common, so you should make sure you understand it. So do you see how cheap this thing is? You're supposed to look and understand what is the question interested in. If you can first get part of it, get part of it. I told you mathematics, especially pure math, it has a lot of numbers. So our role is to give you the techniques, the concepts. Then practicing a lot is yours. That's why we give you consultation numbers, so that you can keep trying and trying without giving up. So is that number okay? Do you get the reasoning I've used? Because now we have the hence part. Oh. If I've told you, when you look at what the question wants you to show, the base is 4. So in the very first step, this one, you cannot use 2. You can use 2 and get the answer, but you're going to rotate a lot. So I said, first create a base for it. Is here. It's what the question wants you to show. Remember I told you that new base you're introducing. If the question doesn't show, now use basics. What are the basics? Introduce the new base as the smallest common factor of what you already have there in existence. Now here, the 2 would be the best option here on the first step. But that's not what the question wants. The question wants a base 4. So I was forced to split on top log x, down log y. Then the new base I introduced, it is base 4. Now, after doing that, I realized that my numerator is already part of what the question wants. It is here, log x of 4. So I realized that I'm only missing 2 over 3 to get what the question wants. So I was given a task of making sure that this denominator gets me that 2 over 3 because it's the only one that has remained to be played with. This one is already in the question, so I'm not going to tamper with it. So I'm supposed to touch this and find ways of how it's going to give me a 2 over 3 on top. Are we together? Then I came and said, now let me deal with the denominator. Now this one, deal with it normally. They are telling you to evaluate this. These are the numbers we have been doing. Evaluate that. It is similar to the first example we did, the one that had 27, 3, and 9. Why we introduced a 3, it was the smallest common factor of 27 and 9. So even here, I'm using a 2 because it is the what? Smallest. Someone may be like, now why aren't you bringing in a 4? Because it's what you said that the question wanted. The question now no longer wants the 4, because you already have it. Now it wants a 2 over 3. So in simple terms, you're supposed to turn this one into a single value. And it's what I've been working on. So since it is 8 of 4, up log 8, down log 4, introduce now this car2. Simplify it like that until you reach 3 over 2. Now, we all know that when you divide 1 by 3 over 2, or every time you have 3 over 2 as a denominator, for it to come on top, it will come as 2 over 3. That is work of P1. So I don't know whether people were telling me to repeat for them, I've gotten something. Someone is saying, Doctor, since 8, I told you before you do that, you're going to get the answer. This is pure math. It always has a lot of options. But I'm telling you what is going to simplify your life. But even 2 will work. But that 2, you will have to change it to 4 in the end. But will you do that? If yes, then proceed. Okay? Now, the hence part. Hence part. They are telling you hence and hence, hence and hence, do something. They want log 6 of 8. Log 6 of 8. But remember they said hence. I remember telling you one time that hence means start from where you've stopped. Start from where you've stopped. Yes, Fred. Yes, Fred, what do you have to say? I don't know. I think people still
Sir,
have issues with using certain Zoom features. Yes, you speak. We are hearing you. The moment you unmute, you begin speaking straight away.
I did not understand the past number, how the X disappeared.
Which X? The
First
X is
scroll
still
up.
there.
First scroll up. Now here where you started log X, logs X of 8 is equal to?
The X is
Here.
there. It is there on
Now where
top.
you circled, from there I didn't understand. From where you circled.
Hey, you will inbox, you check in the chat, those people who have said everything is okay. You take a screenshot and you ask for their WhatsApp number in the chat. Then you send it to them to explain. Because I've explained it 3 times. Maybe you had issues with network. So those people in the chat, put your numbers, inbox the person who has spoken, help them out so that we can proceed. That's how we save time in these classes. You understand, you hope, friends? Other than me repeating a cheap thing over and over unnecessarily. Okay, so this is what we got. I want to teach you how you deal with hence questions. We have this. This is 2 over 3. then this is log. Are we together? And then the next number is the most important one. Go back to the group and call upon scholars to come. The next number, that one should come in your name. Not even should, it is a must, it is going to come. So x of 4. Then they said hence, they said hence log 6 of 8. That's what they said. If you can look critically, then they provided something. So the question is, how do you handle such things? When they say hence, please start from where you've stopped. If we use anything else, they will not mark your work. And students, that's where students normally go off. Yeah? So we are going to do it in a very funny way. How and what do I mean? When they say hence, they want you to compare the two. What do I mean? Compare, you'll be like, this is log, this is log, this is 8, this is 8. So it's like where there is x, they have put there what? 6. So even as you're equating it, you're supposed to say, so this one is 2 over 3, then log 4, then you put here also x. You understand? Which is 6. That is it. That is it. That is it. But now they want evaluate, they want the value. Now when you look at this question, they said that please and please evaluate this if log 3 of 4 is this. Now they have a reason why they have given you this value. They're trying to mean that you're supposed to use it, you like it or not. So introduce a 3 somewhere. Because now here you already have 6 of 4. You already have 6 of 4. But they provided the value of 3 of 4. So introduce a 3. They're even giving you a cheat code. So how do you introduce that 3? You come and say this is 2 over 3. This is log. This is 4. How to introduce a 3? You put 3 times 2. Like that. 3 times 2 is 6. But you have introduced the 3 in the question. This lesson is so good that you're learning the concepts at the same time question approach. Something that we don't normally do. You see? So that is a very good tech. So after that, now you split. Do you know how they split? I taught you splitting in indices. Now it's high time we did split here also in logarithms. So you're going to come and say, this one is going to become, the 2 over 3 is going to remain. Are we together? Then you're going to have log. You all know the mere fact that these ones were multiplied, that means before they were separate but added. You get? So you should have log 4 here, then also plus, then also log 4 here. Are we together? Then have a 3 here, then a 2 here. Isn't it? You all know that this one is the one that takes us back to log 4, then 3 times 2. Why are we really splitting this? We are splitting it so that we can have this value, because this value is there in the question. They gave it to us as 0.792 0.792. They provided the value, isn't it? So this one is just a normal value. Now the question is, how are you going to handle this? How are you going to handle that? How are you going to handle that? Because its value wasn't provided, that means they believe if you are a true math student, you can struggle with it and actually get it. Are we together? And who can really fail that? So this one, you have two options. You have two options. You can deal with it in two ways. Someone can say, for me, I'm going to just use the reciprocal law. I say 1 out of log, so that this one is log 4 of 2. Isn't it? Or someone can say, for me, let me use change of bases, because 2 and 4 have a common 1, 2. So you even say over log, this one 4, 2, hope we are together. But have it in mind that this one is going to take you back to as if reciprocal. You know that people are seeing that. So do you see that reciprocal gave us this one directly, okay? Then that one we really wanted first use change of what also arrived at the reciprocal one. You get? So at this point, I just believe that everyone knows that log 4 of 2 is 2. Who doesn't know that? Eh? I can first brief you here. Look here. Log 4 of 2 is the same as having 2 here. So I'm here. Like we're having 2 power 2. And so, then when 2 goes the other side, what do I remain with? I remain with 2 of what? 2. Then you all know I will have 2 times 1, which is 2. That means this thing you're seeing here, this one, you should sleep knowing that this one is a half and you can prove it. And this is one of the things students do not know. I know that people are with me. I don't know, I may be alone. Have people gotten how that thing is reducing to a half? Whether you go through the reciprocal and reach very fast, or you go through the change of base, but still you arrive at that. Are we together? Are you seeing how the half is coming about? Don't forget this one out of it. Here I just took on the denominator alone. It gave me a 2, but remember before we had this one out of. So that's why I'm saying a half. Are we together? This how the half is coming. You people you speak, you're too many here at a very weird time. It's midnight and you're too many people on, unless people are sleeping. But are you seeing how the half is coming about? Can you proceed with the number and get the final answer? Do I really need to proceed? Because now we have the value of this. This one is just 2 over 3 and this one is a half. You just press your calculator and get the final answer. Okay, people, that's how the numbers are supposed to be done. Log 2 of 4 is a half. Whether you use the reciprocal law or you use the other change of base. And you know why the new base we are introducing is a 2, because the 2 is common to 2 and 4. Yeah? And log 4 of 2, you should be understanding that it reduces to a 2. How? 4 is 2 power 2. So the 2 goes. 2 of 2 is 1. 2 times 1 is 2. Yes, Anena, let me hear from you. We do the next thing.
Okay, doctor. Me, I'm already having an issue because is it a must that when they give you the hints, you're supposed to redirect it to your answer as a must when you have a hence part in your
Yes, I
in your
said
question?
that. I said that. When they tell you hence, you simply begin from where you've stopped. You have no shortcut, you have no option. You're supposed to do that.
Okay, doctor.
Yeah. Okay. Now, I think we need to now handle some of the solutions. Yeah, we need to do some solutions. Now, this one I'm going to just give it to people as assignment. Let me tell you, these numbers are very many, they don't end. So maybe as we do other things, you can be struggling with this. So you're proving that I always tell you that if you're to handle these assignments of math, you're supposed to first do my numbers first. After doing my numbers, then you can do the rest, or you can do other things. So I believe people have continued and have gotten the answer. So people are going to struggle with that. The good thing, it is a proof. So struggle, 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 and struggle, struggle, and struggle, struggle, and struggle until you reach the answer. And it is not hard, it is very cheap. Very cheap, very cheap. So you struggle. So I think I should also put for you the hence part. Yeah. Let me also put for you the hence part. Hence, evaluate so that people can connect well. Hence, evaluate log 4 of 6 if log 2 of 3 is 0.631. Yeah. You take a screenshot of that number. You go and struggle with it. Yeah, other numbers, you'll find so many questions. So many questions. They don't end. But you just need to look for more numbers and try out, okay? So as we do these other things, we should be trying out, yeah? So the task is to hunt more proofs and do them in groups, yeah? So now we are going to solve equations until we end the class. Hunt for more proofs. And discuss as a group. So I've told you the next question I'm going to do is an equation. And you like it or not, it's supposed to come in your name. Hunt for more proofs and discuss in groups. You see what I like about this current era of education? I have the proofs here, but I am not going to give them to you. For me, I just want you to try that. Try mine and try that. Wait for an exam, you will pass. But I've told you proofs shouldn't worry you because there are too many, they don't end. So there are a lot of books they usually share on social media. So what you're supposed to do is to look for them. Look for those books. Then for you, look for only and only equations. Or you look for only and only proofs and then you do those. But you discuss in groups. Is it okay? So there are so many proofs. If I'm to put them, I may not end. But try and look for them. When you look at their solutions, because I've taught you the basics, you'll be understanding. Look at how they have been discussed, now go to another thing. Just because proofs usually make your minds so tough, and then you get confused. So let's now solve equations. Yeah, the equation I'm going to put, you like it or not, is supposed to come. It's supposed to come. It is supposed to come in your name. And this kind of number, when you pass it, you will enjoy equations. So we are going to begin with the UNEB number. It is UNEB paper 1 because this is pure math. (2015) number 3, those with question banks. But let me ask, you the people here are too many. The people here are too many. I don't know whether everyone who is here is sober. Now, to check whether people are really listening, there are those even who are on TikTok, but they are just listening to the voice and just proceeding with their own. I want you to I'm not even going to say the word. You write for me this word in the chat, whoever is active. You write for me that word in the chat. I see the people who are dozing and those who are not. You write that word on the screen in the chat. I see out of this big number. Don't write it more than once. Only those who are active. Only those who are active. Galaxy something, you leave our screen. I'm going to remove you from the meeting with your scrot excitement. And you will not like it. Get something else to do. Don't write the word more than once if you're one person. Do you see? I want you to realize now the people who have written are now 70. But still, you're still too many. You see? Some are nonchalant. And the introverts, they want the number to first reach 90, then they say something. Okay, I think that is enough. I think about hope no one has sent more than once. People have tried. Okay, that's a good number. 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 And let me hope whoever has text or someone sent more than once. That's the problem of dealing with local personnel. Okay, still we are solving for x. So this is one of the numbers. I got it from I told you need to be very careful with UNEB questions because even those of old curriculum can be turned into scenarios. Okay. So it is like that, log x plus 3 of a plus 1. UNEB number 5 marks. They just turn it into a scenario and give it 5 scores. And then you complain, you see. Then this side, we have 2 log. We have 2 log 2 of a like that. Now, I told you, the moment you see that here x is down as a base, sorry, a, and then here a is on top as a number, you just know they want reciprocal. But remember, they need the value of x, and it is not good for x to be down in the base, yeah? That means we are going to apply reciprocal here, that is after the weighing scale. Because now when you apply reciprocal here, yes, you will have put a on top, but then the base is having the unknown, which is not fair. So don't tamper with this, which has the base on top. Tamper with this that has the unknown in the base. And thank God it is already 1 out of. So you're supposed to simply eliminate. So you're going to come and have your a here. This one is going to be like this. Are we together? Then you're going to have, so a will go down, then x will come up after the 1 out of disappearing. Are we together? Then what are you going to have this side? You're going to have log. I told you it is hard to deal with anything if you still have the coefficient here. The best thing is to take it the other side, but it comes as a power. This will be 2 power 2. So realize we have applied reciprocal law, but we are going to go back to the concept or reality of equality, where we are going to have a common base throughout and we are going to equate the numbers. So guess what? Base A, base A, base A. You get? So I will have log A common. Then I'm supposed to multiply these ones. So I'll have x into x plus 3. Then this side I will have log. This will be A. Then this one will be 4. Are we together? So what will you have? You'll have x squared plus 3x. This one will be 4. Do I really need to proceed from there? Because all of you can proceed, isn't it? I don't really need to do that. You can see log. Then also here. Hey, what is this? I think I'm starting to get tired. So you need to just get the whole of that and equate it to 4 and then get the value of x. Yes, Eddie, what do you have to say? People, should I go to the next number? If you're saying I stop there and go to the next question, you just tell me proceed. Write P in the chat, I write the next question. Now the next question has an idea like that in indices that also involves solving equations, the ones we looked at in lesson 2 of indices. I don't know how come that we had 2 parts for indices and we are going to have only 1 part for logarithm. I don't know why it's like that. I don't know how fair. Ed, you speak. Your mic is on. You just speak, we shall listen.
Before you multiply here to go the log down here, here I'm seeing the log of x and 2 bracket x plus 3. Okay. How comes that here you have x down here?
I'm not getting your question.
How comes that here you have log, like, how comes that here it is log x of a and 2 brackets x plus 3? How comes that you get that x? Where are those 2 x's coming from? I thought it's coming
You man, this is addition. And we are adding logarithms with the same base a. So you're supposed to multiply this with this. That's what I'm doing. Yeah. You help him in the chat. We are adding 2 logarithms with the same base. So you're supposed to multiply the numbers. And that's what I'm doing. But seems you are not very attentive in the beginning because these are numbers that were there before. Just because we have applied the reciprocal law once. So Have it in mind, wherever you tell me proceed, it is you people to proceed. So proceeding is your assignment. Every time we agree that you can proceed with the next thing. Okay? So equation 2 is also in ebb number. Yeah? And when you understand this, the lesson is done. So this is the last thing you need to get. When you understand this, please, you can log off. So it is paper 1, 2013. And it is number 1. For me, I'm enjoying. I cannot leave. For you, go. For me, I passed. I don't know if you are passed yet. Okay. So now, what are we solving? We are solving something like this. This is x. This is 5. What do we have? Plus, this is 4. This is log 5 here. Then this. Then 4. Now, are you seeing that number? Now that number, it's very clear that we are supposed to apply reciprocal at least. This is 5x, you see here, then here it is x5. But then it is you to choose where you're going to do everything from. But remember we said it is very bad for the unknown to be in the base. That means when you apply the weighing scale, it will ask you to convert this or to make it the reciprocal. So you're supposed to come and say this is 1 out of, this one is log, now x will be like that. Hope we are together. Then when you come here, you just leave it the way it is. So what do you have here? Just 5, then this one like this, then this one will be a 4, like that. Now, do you remember in indices where I was saying that you're supposed to first create a single power, maybe like that, maybe 3 power x, maybe 2 power x, and then you give it a letter, maybe y, like that. It is the same thing we are going to do. Though this time around we are going to be dealing with the logarithm. So this thing you're seeing common, this one, this, it's what you're going to give a letter. So you're going to come and say let, because the thing is common. So you let it to be any letter, let's say y, like that. So you start and say 1. Of course, you use a letter that has not been used for y equaling to 4. And you all know how to deal with that, isn't it? To deal with that, you multiply by y throughout. When I multiply here by y, okay, let me put it for people. Throughout by y, because of this y, you multiply by y throughout, even here by y. Okay, so here I get 1, then here I get 4y squared. Okay, then the other side I get 4y. Then after that I can remove this. But for in an exam you can't, so you need to have that math. And your work needs to be very neat. So after that, you can now come and rewrite it quadratically. You begin with the 4y squared, then you say minus 4y, then you have plus 1 on the same side, equate to 0. Then after that, you have your factors. You have your factor. I told you this is A level. They don't want to see those things of sum. You just replace straight away. So the sum is negative 4. You write for me the product in the chart. The sum is negative 4. It is here. Write the product in the chart. I look at it. Write the product in the chart. You see someone is saying 1. Those are people who don't follow. And I told you at the beginning. To get the product, I told you you're supposed to multiply this and this. Why sometimes you only consider this? Because in most of the cases here, it is just a 1. So the product is a 4. So those two numbers, which when you add, give you negative, and when you multiply them, give you this. Ask yourself, how do I get 4? 1 times 4 and 2 times 2. 1 times 4, there is no way they can interact in addition to give me negative 4. But 2 and 2 can. How? Negative 2, negative 2. These are the two factors. So how do they work? They replace the sum. So you come and have neat work. You get? Come and have neat work, replace the sum. Come and say this is y squared minus 2y minus 2y plus 1 equal to 0. Then you know what to do. Here you pull out 2y because it is common. You remain with 2y minus 1. I told you when you have nothing, what did I say? When you look at this, you have nothing to pull out here and here. What did I say yesterday? What do you do when you have nothing to pull out? What do you do when you have nothing to pull out? What did I say the other time when we are covering indices? What do you do when you have nothing to pull out? Let me see if I'm going to pull out a 1. Thank you so much. Thank you so much. We pull out a 1. So you're going to come here and say minus 1. Then I told you, what did I tell you about this bracket? If at all you don't want to stress yourself, what did I say about that bracket? Because in most of the cases when you pull out a 1, it gives you a time. What do you do for that second bracket? I said something simple. You text it, you just copy from the other. Thank you so much. Hey, those people are going to be following whatever I tell them from day one. You're going to pass. You're going to pass because in 1 year we shall be done with the work. You have a full year to repeat whatever we did together. And then you fast. You read as you fast. Then God will give you the points you need. If He doesn't give you the points you need, just know He has a better plan. You like it or not. Because you've read, you've passed, you've fasted, you've been doing it all. So you realize 2y minus 1, even the other one is 2y minus 1, so you just square them. Square root of 0 is 0. So you have 2y equal to 1, you obtain your y as what? As a half. Hope all mathematicians are there. So for you, you've gotten the value of y. But that's not what they want. First, you want the value of x. You go back to what you let. You let log x of 5 be y. So you're supposed to come here and say, but I was teaching the relationship of log and indices, but people were like, why are we really wasting time there? Now it is time to perish. Log x of 5 is equal to y, and in this case, y is what? Y is a half, okay? So what are we going to get? Convert it into index. Tell me the conversion. Don't give me the answer. I just want you to tell me the conversion into an index. Tell me the conversion. How is it going to look like after converting? I don't want the answer. I want how it's going to look like after you've converted. How is it going to look like after you've converted? How is it going to look like after you've converted? Exactly, but you're missing the x equal 2. You're just telling, no one is writing 5 root 3, sorry, root of 5. Okay, 5 power half. I told you how to put in these things in the calculator. So you put in everything, you write your answer to 3 dp's or any dp's that you want, then you underline. You look at that number. Is that really hard? Reciprocal law, a unib number. I think we should do another one. Yeah, I think we should do another one. And this other one has a technique. Yeah, it has a technique. It is the same as the previous one, but it has a technique. And it was set in the previous year, that is 2012. It has its own technique that we are supposed to give time. Then the next is worse. Then the rest are cheap. So we are remaining with only 2 numbers to end the class. Yeah, I don't want to do a lot of numbers. I don't want to do a lot of numbers. So let me hope that number has been gotten, yeah? Especially that point where we let and first get a certain value and either we bring it back, then we convert the logarithm into an index. That's why I gave the relationship time, because I knew we would need it in the future. Okay, now question 2. an equation. So that means these numbers, I'm going to be stopping somewhere, then the continuation is yours. So we are solving for x, and it is a unable number. Of course, it is paper 1. I've told you it was the previous year, 2012, and it is number 15, part B. And the moment you hear section B, just know it was 6 marks. That means you're not. And I told physics students yesterday, but in every lesson that we have, imagine you introduce the topic. Now we've covered logarithms today, and we are already doing unable numbers on each and every concept. That means we have moved. Yes, we have moved seriously. In normal school, you can have about 3 to 4 classes of logarithms, but shorter ones. Why I prefer these classes, you have one long lesson. If at all you've not been disrupted by anything, one long lesson and it is finishing it all. So it's about how determined one is, okay? So we are solving for x. We're having log. We're having x squared of what? Of 4. This is minus. This is log. This is x of 4. Are we together? Minus 1. This is 0. You get? Now this one is a bit hard. But do you remember when I told you that it is hard to apply laws of logarithms when you still have a figure here? But remember that was some other things of evaluating and simplifying. These are equations. Now we realize this one is still x squared. So there is a way it doesn't want to completely resemble this. Do you know what you do? You simply just bring that to there. You don't shout. But I've copied this one wrongly. This one is, we are having 4 on top here. We're having 4 here, then x is the one here. So realize this one is x squared, but this one is x. I'm talking of this. This one is x, but this one is still x squared. So you need to first have it as what? As x only. So you're having x here, then this one you're having 4, then you're having 6, then you're having log. Having like that, then this one is minus 1, then this one is 0, like that. Now, as a person who really has a keen eyesight, you see, you see that, then you know that here it is none other than reciprocal law. Now the question is, which one are you going to change? Let me not say a lot this time now. Let me first ask, are we changing this one in the first box, or we are changing this in the second box? Which one are we changing? Which one are we changing? Are we changing the one in the first box? We are changing the one in the second box. We are changing the one in the second box because it's having the unknown in the base, something that is really poisonous. Okay, but now, okay, we are changing the one down. Of these ones, which one is the right thing? Are we going to have the answer as this? We are dealing with the reciprocal. Okay, x on top, then 4 down, or it is supposed to be like this. So of this first and second, which one is the right way? Which one is the right thing? First one, second one. First one, second one. You people, you know math. It is the second one. But this code not only knows math, not chemistry and biology. Yeah, it is the second one, because now how 6 is not even involved in this. It is just a constant on its own. It doesn't even know that all this is happening. So why involve it where it wasn't, or where I didn't ask to get involved? So you're going to have 2 log x of 4 minus 6. Then here you have 1 out of log x of 4 minus 1 equal to 0, like that. 0k. Now when you have something like that, you let. So the technique I told you that was different for this one is how to ensure that you leave 6 where it is on top, and then you just deal with the logarithm alone. Do you see that? So you come and let, you can say set. I used to use the word set because all my friends were using let, and I wanted to be different and extraordinary. So I used to use the word set, suppose, such words, set. But don't copy. You may set and have wrong answers. For me, I use not write wrong answers. 2y minus 6 over y minus 1 equal to 0. Like that. Then you know that the y is supposed to multiply everything. So this one will become 2y squared. So it will be minus 6. This will be minus y. This will be 0. Then what will you get? Be 2y. This will be minus 6. Yee. As if we are doing O-level math. Now you look at this thing. The sum is -1. The sum, -1. The product is 2 times -6, -12. The figures that multiply 12 and can interact to give me 1 is 3 and 4. 2 and 6 can't, 1 and 12 can't. How do I get -1 from 3 and 4? By saying -3 plus 4. Or what I can call 3 minus 4. What am I getting? Sorry. The figures that can be multiplied to get 12 and can interact to give me a -1, it is 3 and 4. How can they interact when this one is a negative and this one is a positive? You see that? You see that? Now, someone tell me, if it is +3 and -4, remember I'm replacing this sum, this one. Am I going to say +3y minus 4y? Let me see people who were extra attentive in the indices lesson. I'm going to say, of 1 and 2, which one am I really doing? And why? I want you to text the reason, even if you don't talk. Text the reason. Remember, the factors are supposed to replace sum. Am I taking 1 or 2, and why? Someone is saying 2. Someone is saying stop there, cheap. No, I don't want to stop here because we are going to get 2 values here. And I want to show you how 2 values are dealt with also. Then maybe other numbers I can be ending where I want. 2 because the sum is -1. 2 because they have common factors. The answer is K. K here said 2 because it is easier to remove 2y. It is option 2 because it will be easy for us. It will be easy for you to deal with 2y and 4y. Then it will be easy for you to deal with 3y and 6. But here dealing with 2y and 3y is hard. So you consider arrangement according to how easily you will factorize whatever you're going to have afterwards. Okay? So that's why I told you that in most of the issues and concepts in math, you're supposed to check on the future. See what the future has for you so that you have you know what to do. Just like the way people say, education, medicine, have jobs. Let me do BCM, PCB, I do medicine. You get? Someone says engineering, if at all I maximize it, the government jobs are very good. If at all I get a good contract and I'm connected. Let me struggle with my physics and math, things like that. So even here, check what is really the future. Is it really favoring or not? If it's not, then don't do the rest. So a serious student should have given me the values already, and then we proceed. Why do I really need to do all this? But no one is giving. That means people are not writing. No one is calculating with me. So this is just y minus 2. So this one is +3. And the bracket should be the same, you like it or not. So the person who had told me to stop there, I think you see what I meant. Here we're having 2 values. And I want to show you how to deal with them. So don't forget the other logarithm we had. It was x of 4. x of 4. So we are getting two values. The first value shall be negative 3 over 2. Is it okay? Then the other one shall be, I think, y equal to 2, like that. But remember, we are looking for the value of x. And so, when you come here and say but, log x of 4 is the one of y. Now I want people to help me. This side, you're going to say log x of 4, and then the y is negative 3 over 2. Yes, people know how to convert. Then this side, you're going to say, so this side, the answer is obvious. X of 4, this side is 2. So this side, the answer is 16. But I want people to get me the answer to this, because yeah, you're supposed to say 4 and the power is negative 3 over 2. So I want to get the answer from you all. This side it is cheap, x is 4 power 2, so x is 16. I also wanted to calculate till the end because I enjoy these numbers. Very cheap. What are you getting? What are you getting? I prefer fraction. 1 over 8. Thank you so much. 1 over 8. And if you're serious, even if you don't use a calculator, you can get the 1 over 8 if you attended lesson 1 of indices very well. So do you see? Unable number, but kinda long, but very cheap. Kinda long, but very cheap. You see? Now we are going to do the next one that has both. But for it, I will stop somewhere. I will not complete it for reasons you know. But it was also set as question 1 still in the previous year, 2011. Yeah? And for it was kinda tough. But it just needed a few steps. Someone who really understands what they are doing. So question 3, it was still paper 1 after doing the previous year 2011. People, let me hope we are still together. You can see your friends are running away slowly by slowly. Yeah. But I always want to teach till late so that I really look at those people who are struggling to make it in the academic life. Because I know people here are tired. Even me, I'm tired. If I tell you my schedule, you may start feeling sorry for me. That's why I don't usually say it. Because if I tell people that I last slept on Wednesday, they can't believe. Okay. This is the question. It was number 1, section A, so those are 5 marks. Do you see? That is the number. So this number, you just look at it, doesn't even connect. This side you're having base what? 5, this side you're having what? 25. This is what I told you, that there are questions that will communicate the best which you're supposed to reduce everything. So here things are very clear that here you have nothing else to reduce. So this one will remain as it is. But this side you're supposed now to introduce a new base which is 5 and you have no option. That is the only option that you have. So you're supposed to come and work on this and split it. You'd be like, okay, on top I'm going to have the log for x squared, you see? Then down, I'm going to have the log what? 25. Okay. Then you introduce the new base. So the question has communicated the new base it wants 5. So you come and put here 5. You come and put here what? 5. Are we together? So as a mathematician, we all know this one alone, this one alone, this one is something. Is something. Because we want to maybe simplify it in one way or the other. And what is that? Look here. It is log 5 of 5 squared. And so, this is how it will become a 2. Because the 2 will go the other side, we remain with log 5 of 5, which is a 1. So we'll have a 2. Are we together? So that means this one is reducing to something like log. This one is still 4x squared. Then down, you're having a 2. Hope we are together. That's what this one is becoming. Remember, this one is still equal to what? To this. What are you really going to do there? What are you really going to do there? Now let me test your math, because here we have two options. Let me first inquire, are we together up to that point? Are we together up to that point? Let me ask, are we together up to that point? Up to this point, how the equation finally becomes this. How the question finally becomes that. Are we together? Do you know why I introduced base 5 as the new one? Because it's what we had on the right, and it is the most simplified factor we have. Then do you get how log 25 of 5 becomes a 2? Are we together up to that point? Okay. I told you, when you say not really, those people who are saying yes, ask one of them for their contact to help you out on WhatsApp. You become friends. We have been teaching since 2016, and so many people have gotten best friends from that Zoom thing you're seeing, that Zoom chat. I think 2 weeks back I attended a wedding where my students invited me, and they found themselves in the Zoom chat. So if you're here and you've been struggling with relationships for some good time, take the Zoom chat serious. You never know, you can find a beloved one there. You start slowly with discussions, both of you pass, both of you go to medical school, and just like that. So that you tell your people at the wedding that I found my person in the Zoom chat in a math lesson at midnight. It was of logarithm. You see? But when I tell you to always befriend yourselves from the chat, you don't want. So that's where we are. Now I want to ask people, how are you going to get the value of x? You think, how are you going to get it? Remember, you look at this. Remember, you have your base 5, even this is base 5. That means you can even just say this one is equal to this. That's what may work. But the problem is this 2. Now I want people to tell me, how are we going to deal with that 2? How are we going to deal with that 2? What can we do? I prefer someone unmuting, so you hear I'm teaching you now the math. Crossover, we cross multiply. You tell me, after cross multiplying, what next? You people, what next after cross multiplying? Then what? After cross multiplying, then what? Multiplying both sides. That is cross multiplying. Introduce unknown. 2 comes in front of the log. After 2 coming in front of the log, we make it a power. After making it a power, we are moving. I'm with Maurice and Fred. Introduce, I'm with Maurice. Maurice, yes, I've made it a power. You people, I don't know if we are together. We have already cross multiplied and we made it a power. After the power, Maurice, remove the log base 5. After removing, what next? Let's first move with Maurice. He has a very good idea. Yes, he has a very good idea. Most of you are saying we cross multiply. You see, this is mathematics. Other methods can work. But I want to move with the mind of Maurice because he's serious. Now, he has said we cross multiply. Okay, let me cross multiply. The 2 is here. Then he has said you make it a power. I put it there. Okay, let me put it here, the 2. So I remove this. Okay. Then Maurice said, because we have log 5 here and log 5 here, then he said we can remove them. We equate the other ones. Okay, I've removed them also. Now that's what I have. So Maurice, speak. This is where we are. We are at this step, and it is right. Hope people have been following whatever I've rubbed. Now, this is where I want Maurice to tell us, Maurice, what next? Now, going beyond that step is what they call being a real mathematician. We take 2 from 4x. I'm not getting. Take square roots on both sides. Thank you so much. You see, opening the brackets may be hard for you, and you're going to create powers you won't really manage. So I advise people to do what? To take square roots. But there is a better option. Taking square roots is for, it's easy, but it is for people who are not serious. But it is good. But there is a better option that makes you a good student of indices. What can we do? Yes, taking square roots is good, but there is a good one I want. There is a better one I want. I want to see it in the chat. I want to see it in the chat. Do you have any other option apart from taking square roots? 2 power 2. Yeah, I think Derek has the idea. So first make this for 2 power 2. This one is x power 2. You get? Such that it becomes 2x. Are you seeing this? All over 2, because 2 and x have the power 2, so the power can go outside. And then this side we have 3 minus x squared, then this one is squared. You see that? So this and this, they are the same, so you equate the bases. You know whether people are appreciating the beauty of math. Yeah, then you arrange. How do you arrange? You can say, let me carry this one where the other side, it finds the 2x as a positive, then also the 3 follows as a negative. And this one, you have not even introduced anything else. You just get the values of x directly. But I don't know if people have been following right from the very first step. I believe when people get the workbook later on, they will catch up very fast. But that is it. So people, can you proceed from there and get the answer? Can you proceed from there and get the answer? But getting square roots was easy. It was also okay. Even those people were telling me, first deal with their half. Those things we are saying, they were all right. But trust me, when you do them, we shall arrive at the same thing. But please and please, a lot of numbers have been done. Make sure you get back, you revise these things. Yeah, don't just sit on yourself. Yeah, now it's quadratic, so you can proceed and solve. Now, this is your assignment. By the way, trust me, most of the things, you can now do most of the numbers. Yeah. You can do most of the numbers. So it is paper 1, 2007, and it is number 3. Okay. So as usual, we are solving for x, nothing else. So what we have here is log x of 2 minus log 8 of x equal to 2, like that. Period. Then I'll also give you this one. It is a nib number. I have a friend who was struggling with this one the previous night. This second one I'm going to give you, it's a question of 2003. I believe they can do it after this. That one is cheap. Of course, it is paper 1. What people are writing? And it is number 5. Of course, it is also solved for x. Log, this is this 4. This side we are having 6 minus x. This one is serious. Yeah, this one is serious. I don't know. Can you really do it, people? Can you do that number? Can you do that number, people? Now, those who are on, I just believe you're very organized people. I just want you to tell me the quadratic equation. Don't solve for it. Get a piece of paper, try to handle this one. Only stop at the quadratic equation. Then, when you get the right quadratic equation, I will consider it as the assignment. The other ones, you can pass them. Yeah, the other ones. Now look at this number. You can really battle it very well. Very well, you can battle it. You can battle it and get it. If I supply change of base after I go for reciprocal. But I'm interested in the second one. I'm interested in the second one. Second one. Second one. Now, you people, let me give you a certain hint here. Are you seeing this canal? This is what I advise. You first write log x, then this one has 2 power 3 because of 8. You get? Then after, you carry this 3 here, have it here like that. So it will have disappeared from there. Do you see that now the question is becoming easy? Because now here you will be having x of 2 and here you will be having 2 of x. Then you handle it like the rest. That's why I'm saying it is cheap. Yeah? But I'm interested in the second one. First, try to get a piece of paper. Tell me the quadratic equation you're reducing everything to. If someone is saying I'm kinda fast, that one is not right. You're lying. I'm fast where necessary because most of the things we have said them. If you're saying I'm kinda fast, you're lying. Unless you've not been with me since the beginning and you've just logged on, then there you can say that I've been fast. But if you've been with me since the beginning, don't say that you're lying. That's a lie. You just come. People having minus x, others having plus x. Which ones should I take? People are giving me something wrong. Yeah, I think I'm getting some good representatives in the chat. Okay, that is good. That is good. Okay, people are trying. That means they got the point. And that is good. Yeah, that is good. But this one is very cheap. Very cheap. Because now this one, what you're going to do, because of this smallest base 2, it's what you're going to introduce this side. Be like, this one is a 2, then this one is like this. Then down, you're going to have log. This one is going to be 4, this one is going to be 2. Now this one is going to become a 2. Now when it becomes a 2, you take it the other side here. Then it will later go to become x squared. So you're going to have 6 minus x equaling to x squared. So the right equation is x squared plus x minus 6. Is that why the person said I'm a bit fast? But if you've been with me, you cannot say that I've been fast there. What have I done? Really? Nothing. The things I've done, they are the things we've been doing. So are we all getting the equation? So people, is that okay? Okay. So you see, things are cheap. Yeah? Things are cheap. Look at the small. So this question has specified the base you should what? You should take on base 2. Introduce it. Down you'll have log 4 of 2. That is a 2. Take it the other side. Make it a power. Because you have log 2 on both sides, equate the numbers. Obtain the quadratic equation, solve it. You have not even introduced the other unknown. You see? So things are cheap, but you're supposed to practice. Hey, don't think they're just cheap like that. So my friend Daniela, is the number okay? Because it's one of the numbers you wanted to understand today. I don't know if the Daniela that is on is the one I'm talking to. Is the number okay? Because you've been quiet for some good time. I don't know if you slept off or you're still here. Okay, that is good. So I'm not going to get tired of giving you more numbers. So another assignment. So those people have put the correct equation intentionally so that when you see someone in the chat who has the correct one and yours didn't come out, ask for their number. Yeah, ask for their number. So we are solving. So this is paper what? Course paper 1. 1990. Oh, the year he was born. Then we are solving, this time around we are solving for n. We are having n here, we are having 4 here. Let me tell you another thing. Yeah? If at all the lesson began when you are understanding and now you're like as if you're not understanding, you're actually understanding. But the difference is that now you're tired. So even the things you had captured, it's as if they are very new. But when you repeat this lesson in your own time and convenience, things will flow again. And you'll be a god in logarithms. Now look at that number. Very cheap. Very cheap. Very cheap. Very cheap. See, another assignment, 1996. But these numbers are mature. 1996, my parents were mating. 9, eh? So we are also solving. This one is not easy. Because this question is hard. Should it really be assigned? But trust me, for me, I believe I've taught you. You may just have that in mind. I've taught you the topic. So I believe you can pass it. Do you see that? At the moment this is change of bases because now you realize reciprocal will not work. So change of bases. And when you use change of bases, how will you fail? How? Hint. Let me give you a hint. You see that this question is easy. You see, this one will be log 8. And so, then down you will have log x. Of course, reciprocal can't work. So change of base is the only option you have. And bases are not the same. So what do you expect? Then down you will have log x squared. Are we together? Then put here 2, put here 2. Then also put here 2, put here 2. Why you're putting here 2? Because it's going to help you convert the numerator into 3. So having 3 over this. Then even here. Do you see that it's going to make your life easy? It's going to help you convert the top thing into 4. Then down you're going to have 2 log x of 2. Can you see that? So can't you really handle that? Who can't handle that? Can you fail to handle that? Because now just imagine the whole of this has changed into this. The whole of this has changed into that. Do you see that even this one is common in red? This one, log x of 2, log x of 2. Can you really fail to do that? Really? Give it a y, struggle with it, get the value of y, proceed and get the value of x. Then you say math is hard. Is it cheap? Is it cheap? Okay. People don't understand why on the timetable I put their nightlife. I put their nightlife because I don't have. This time around, my workbooks have 20 pages. I have reached the 17th page. That means this is the longest lesson we've had with a lot of numbers. Okay. Yes, we are still moving. Assignment. I give you assignment. I even give you the hint. The lesson has ended. Yeah. Hint. So assignment. Log x of what? Plus. This one is 64. Okay, then this is x. This is 5. Look at that. Yeah. You people. This one is just the way it is. It doesn't need to be touched. You mean to see 64. Change of base. But what is that new base you're going to introduce? Has the question communicated? Yes, that what? 2. If the question puts here 4, then you're supposed to also put here 4. The question put here 2. If it doesn't communicate, use 2 by force because it's the smallest factor. Then down you'll have this one will be x, this one will be 2. You see, it's even going to be similar. This one is going to be similar to this. So you give it a letter y. This one is turning into a 6. Who doesn't know that this one is 2 power 6? So the 6 goes, you remain with 6 log 2 of 2, which is 6. Yeah. Logarithms. I don't know why the whole internet, every student was telling me logarithms, 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 logarithms. But now, what are they? It is 1995. I think here they were conning each other. We have another one, 1994. The environment is quiet. I don't know if people are still here or sleeping. 2A. Hope you're writing. People should be writing notes and calculating numbers. I'm giving you a lot of work. So of course we're also solving. Log x of 2 plus log x of 4 plus log x of 16 becoming 21 over 16. Can you really fail to do that? I think that one is also very cheap. Yeah, I think that is also very cheap. Because you can write all these ones. You can write this one in terms of this. You can write this one in terms of this. I think it's not hard. It's not hard. The problem may be people may think that every time you may need to convert, or maybe to bring in a new unknown. But this question is special because you can see x here, x here. But even if you bring the unknown, the thing is about you getting the correct answer. Even if you bring in y, are you listening? But later on from y you get x, that is all. But let me show you something simple here as the hint. If at all you come and say this one is just like that, perfect. But then when you come here, you have here log x, you have here down log 4. And you know what we are bringing is 2, what we are bringing is 2. Then you come also the other one, you have log x here, then down you have the log 16. Then you know the base you're bringing is 2, then 2. Then the other side, you have the 21 over 16. Are we together? So after that, you'll be like this one. You all know the whole of this becomes a 2. Not so. So I can remove it and put 2. Hope it won't confuse you. You see the advantage of attending live classes? Then I'll also remove the whole of that. It will become a 4. You all know log 16 of 2, eh? Log 16 of 2. Remember 16 is 2 power 4. So when 4 goes the other side, it remains log 2 of 2, which is 4. Eh? So remove that. Now, when you reach such a step, even if you don't waste your time to say let it be y, but you can put here the y, you can put here the y, you can put here the y, you can put here the y. But the advantage with this number that it is on top throughout. So you can pull it out. So when you pull it out, here it will remain 1, here it will have remained a half, then here it will have remained what? A quarter. Then this side will have 21 over 16. Are we together? To check that people are really still on and sober and following, you tell me the value of this when you press your calculators. I tell you. You tell me the value of that when you press your calculators. You tell me the value of that when you press your calculators. What are people getting? Okay, people are getting 1.75. That is good. That is good. Now, what you're supposed to do, press this. Are you seeing this 21 over 16? You say 21 divide by 16. Then you say divide by answer. Then you tell me what you get. I don't know whether we are together. That answer you get after adding all this, you're supposed to divide it by 21 over 16. So you say, open brackets, 21 divided by 16, close brackets, divide by answer. What do you get? Hurry, hurry, hurry. You're getting 3 over 4. That is good. So 3 over 4. So do you see that now you can get the value of x without even you bringing in the value of y? So how have I realized that? But if for you can introduce y, it is okay, you can have it. But for me, when I looked at it, I saw x on top throughout. Then I was like, this one doesn't really even need the value of y. But if for you bring in y and later get x, you shall arrive at the same answer. So you press this and get the final answer. Yeah? You can write it to 3 dp's, you can write it to 4 dp's, you can choose to write 4 dp's. That's in case the question has not told you to which value or to which level of accuracy you should write your answer. You see? All these ones are supposed to be assignments without even giving you hints. Just cause me, I just love calculating. That's why I'm keeping you here. Okay. Assignment. Let's see. Okay. Now this one is going to be research because they are simultaneous equations. Yeah? Do you remember that even under indices I gave you simultaneous equations? So research, simultaneous. So you copy them and then you go and discuss and enjoy. So the moment you see research work, the lesson is done. But I want you to look at these numbers. I don't know if they may be hard for you, but you look at them. Are they hard? I really don't see them as hard questions. You look at this one. This one. They said 3 power x is equal to 10. Find x. So you introduce log 3 power x. Even this side you introduce log, it is on 10. Then you drop this x. So you have x log 3 equaling to log 10. You see? So to get x, you divide by log 3. To get x, you divide by log 3. Then you press the calculator. Isn't that really so cheap? I don't really see a problem there. Is there really a problem? Then this one we solved in indices, no need. The only hard question I see is here. It is here. This is the only sensitive. Yeah, this one is sensitive. And please take it serious. Most students fail it when it is said. But I believe the other one, very cheap. It was even covered the other time. So I'm just here just to give you those numbers of simultaneous equation. Then you go. The class is done. But thank you for attending. So you look at this thing. Is it really hard? I may be just hyping it, yet it's not actually hard. So they give you such a number and ask you to get the value of x. This one, this one, this one. So let me just show it. Let me just show it from here. I don't usually want to explain already done math because it usually gives students hard time. But let me go through it very fast. So this is the question. They ask you for the value of x. So introduce log. Then after these powers are supposed to fall down like this, like this. So when they fall down, you're supposed to open brackets. This x should multiply log 7, even this 2 should multiply log 7. You come up with something like this. Even this side, this 4x should multiply log 5. Even this minus 1 should multiply log 5. So you get something like this. Now the logic is simple. Since we are looking for this value of x, this one and this one, you get those ones with x and put them on one side. You get, whether we are together. So this one, the 4x log 5, you put it on the same side as this negative x log 7. What is the sole aim? The sole aim is to pull out this x because it's the one they want. So when you pull out the x, you realize you remain with 4 log 5 minus log 7, which is inside. Then these other ones, you take them also on one side. You see, you'll have the 2 log 7 plus the log 5. Then after you make x the subject, you press your calculator and get the answer. Do you see that they are not hard? It's just logic. Is it really hard? Let me tell you, even if one person remains, for me, I will teach. You joke with me. Yes, you're tired. Even me, I'm tired. But this thing is not hard. After the lesson is done. The lesson got done 30 minutes. But I'm keeping you here to teach you endurance. But you're not clicking that. You think me, I want to be here? The lesson got done long time. The lesson stopped on law of change of bases. After you learning it, that's where the lesson stopped. But I'm keeping you here intentionally. So let me hope you've got that. Drop the powers, open brackets. Now when you open brackets, those things with the unknown you're looking for, put them on one side. Why? You pull it out after you divide and get the answer. Yeah? But always teach yourself to take screenshots where you've not understood. Attack our consultation lines. Ask people in the chat, in the community, things like that. So, people are saying not hard, not hard. Okay, I want 20 people. 20 people to tell me that they have understood that number. Only 20. So the 20 people will represent the friends. 20 people, I'm starting to count now. 20 people. The first one, if you've understood that number, those are 2. Don't write more than once. Those are 4. Don't write a message more than once. Okay, got it. So you're supposed to take a screenshot, copy the number first, write, then compare it with what is on the screen or what you will have screenshot, things like that. So, introduce logarithm, lower the powers, open brackets. Since you're looking for unknown, put everything on one side. Divide throughout. I think that is all. These other things are cheap. See, even these ones have simultaneous equations. Okay, let me give you the simultaneous equations. We leave this place, you see, reciprocal law, very cheap. Then this one, very cheap. The good thing you have this book, This book is there on the drive. Yep. So let me give you Bambi the research you go. Sorry for keeping you here, but feed it. Okay. But have it in mind, senior 6 topics we already taught. Yes. So the only lessons we shall have are revision questions. Lessons. I'm actually tired. The moment I start speaking English words that don't coordinate. So the first case 1, we're having log x of 10 plus, so you copy log, we are having y of 10 equal to 1 is 0k. Then we are having log so never ask me for the ending time of the class. What really drives the class are the lesson targets. If I say we are completing logarithms, we are completing. For me, I'm determined. I'm determined. Extremely. Okay. Yeah. That is the first twin. That is the first twin. Okay. This one is difficult. This one that I'm going to write next. But you can even answer them, yeah? You can answer them. Though I'm putting them as research. These ones cannot fail. And they're actually unique numbers. But they are mature. This one is a number of 1992. This one is 1990. Okay. Then this one, you can do these numbers. Very cheap. So people have been writing it. I always tell you that is very key. You write as I write, you write as I write, you write as I write. Okay. So let me put the last question. We go and sleep. But for those who are sober, yeah, for me, I'm going to stay for consultation. So you can give me a call after the class. So this is pair theory. So these numbers are easy. For you, just try to write them in terms of normal stuff, yeah? But they're also very old. You people, I think that is enough. Okay, that is enough. After all, education is not the only key to success. That is enough. So that is the end and the hint. The hint is easy. 1, you're supposed to eliminate logarithm. Eliminate log. Eliminate log. And when you eliminate log, solve the remainder. Solve the remainder normally. So these ones, let me just speak about them. And I think maybe people can try to understand something. Yes, I told you I'm going to keep you here. I'm not supposed to go beyond 1, yeah? So remember this one is base 10, just because they are not telling. Even this one is base what? Base 10, even base 10, because they have not put it. Now you know that this one is x plus y equaling to 10 power 1. You understand? That is equation 1, because 10 power 1 is 10. Do you get? So you eliminate the log so that you come up with these equations that are normal. So you solve simultaneous. When you come to this, first get this 2 and make it a power here. Are we together? So that it becomes y squared. So here it will disappear. You see? It will disappear. This one was a 10. Now when it disappears, guess what? You will have log, which is having 10 here and 10 here. And this one was subtraction. So we are going to divide. And we shall have y squared over 30 minus x. And guess what? It is equal to, this is 0. But don't forget that you have a 10 there. So that means you're going to have y over 30 minus x equaling to 10 power 0. But remember, 10 power 0 is 1. So I remove 10 power 0 and I put what? 1. People, this is equation 2. So you battle and solve equation 1 and equation 2. And I believe whoever is here can give that one a try. As a mathematician, at least those two you cannot fail that. So out of the power here, still I need 20 people still. I'm going to count you. I'm going to count you. So the people, 20 people to tell me that they have learned what I meant by eliminating log and solving the remainder normally, like these other normal equations. 20 people, I'm going to count you. You say I've learned. That is 1, Ibrahim. Those are 2, Derek. 20 people, 3, 4, 5, 6, 7, 8. Not yet. You look for the contact of those saying they have learned. Not really. You change combination because you're not fit for it. Okay, I think people have reached 20. Okay, that is good. That is good. So things are cheap, yeah? Just feel the urge. Just be like, yeah, logarithms, I know them. Then convert, find ways of eliminating them, come up with normal equations, solve them simultaneously. I told you I'm not supposed to go beyond 1, and it is just 1 minute to 1. So allow me sign out as Paul Tutor, a tutor of science and math at Science Scholars Academy Uganda, based in Uganda, the academy that creates students that are competent. And this is my personal number. Yeah, it has active mobile money. Okay, so if I think it's exactly 1. Thank you for attending. Thank you for being endurant. Those who are thanking me for the lesson, I don't have free lessons. I don't have free lessons. So I will not really identify you. Okay, I don't have free classes. Okay, people, bye. We meet next time, inshallah. Every document we have used, I'm going to make sure I provide it via Drive link. And maybe it should also be in the description of the video once posted on our YouTube channel. Otherwise, big ups to Science Scholars Academy Uganda. Bye-bye. Yep.